So that's why the high nighttime high concentration is maybe because of the low temperature and low wind speed. And they also, if you check their backward trajectories, they are come from Arabian and Thar Desert. So Arabian and Thar Desert is also well known for the dust storm, means soil particles. That's why these two regions are actually behind this higher concentration of this soil in during daytime and nighttime also. So the arid region of Africa, that is the Saharan Desert, and Middle East, that is Arabian Desert, and Thar Desert are some of the hotspot of the world and contribute a large fraction of mineral dust to India. So these regions are actually well known to transport the dust particles or soil particles to the Indian continents. And during the African and Arabian dust outbreak, the concentration of cluster elements were reported to be higher. So this high concentration during dust events is also reported previously by other study that they have contributed significant concentration of calcium and silicon to the Indian continent. That means these are the very well known source for this soil particle for India. And if we see their yes, so this calcium and silicon ratio can be used to categorize the dust particle. Like Saharan dust have a different calcium and Si ratio, and Arabian desert have a different calcium by Si ratio. So we can differentiate based using this ratio, that whether they are coming from Saharan dust or whether they are coming from Thar desert. But if we see the uh, the ratio are a little bit similar. It's a zero point 0.3 and zero point 0.4. So it's not the average is 0.3. So it's not a very big difference between this day and this day. So this may be because of the mixing of this Arabian and Thar desert dust together before coming to the Indian continent or before coming to the sampling site. That's why these ratios are similar, although they are originated from Thar desert and Arabian desert. But during the transport, they are intermixed into the atmosphere. That's why the ratio of this calcium and silicons are similar for these 2 days. And if you see the daytime mean concentration and nighttime mean concentration of sulfur were also comparable. This is because of yes. So sulfur is basically emitted from coal burning, and we know most of the coals are used in India for power plants and power plant, and also for combustion activity like cooking food or something like this. So this power plant activity and the cooking activity is common, like they are always present. That's why there is a very low similar concentration during daytime and nighttime concentration of sulfur, because SO2 is always there into the atmosphere, whether it's a nighttime, whether it's a daytime. And highest concentration of sulfur was occurred on 25th of the January during nighttime, and during daytime it is occurred in 23rd of the January. So when we check the this why it is higher using backward trajectories, so they identified the northeast and north central India region, like the all the air masses were coming from these two regions, north and north central Indian, as a potential source and preferable transport pathway. So if we check, this is actually Indo-Gangetic Plain. These two regions are actually Indo-Gangetic Plain, and Indo-Gangetic Plain have a huge sources of these sulfur, because they have a shallow boundary layer, and all the emitted aerosols from Indian continent, even from the transporter, they are accumulated in this region. So they can also transport it from our side. That's why the concentration of this sulfur is was higher during these 2 days. So seasonal variability. So when these are the um, measured concentration, and this is a various season in 2012 and 2013. For these are only for the cluster element. So most of the chemical species was elevated during post monsoon and winter, as compared to the monsoon and pre-monsoon season. So if you see the cluster
Sir, due
elements
to
in
time restriction, please conclude the session. If you
okay sir.
you can take 2 3 minutes more, no problem.
Okay sir. Okay sir.
Yeah.
Okay, so Okay, so if you see, the concentration was actually higher during post-monsoon and winter season as compared to monsoon and pre-monsoon season, and the cluster elements are higher during pre-monsoon because of the wind blown. And other elements, if we're talking about the sulfur, is as highest participants during almost all season. As we know, sulfur is emitted from power plant and coal burning, so they are that's why they have a less infected by the seasonality. Other elements have a less seasonality because they are emitted from various sources like anthropogenic activity by traffic emissions, many things. That's why they have a less seasonality. So here we can see the potential pathway. So where during the K-mean clustering, we can see these are the clusters. Total there is a 5 clusters. So 5 cluster is categorized. So cluster 5 is actually associated with the um, we can see the cluster 5 come from the Arabian Peninsula and Thar Desert, and this cluster 5 is actually associated sorry with the dust storm. So and the other if you see every year the Gangetic Plain are significantly influenced by the transport of dust originating from the Thar Desert, and this meteorological situation can be give rise to the transport of fine dust to the VVNP site. So sulfur concentration was associated with the cluster 4 were higher than the other cluster. So if if we see the cluster 4, this is cluster 4, they are coming from this region, which is very well known for the power plant and coal burning emission. That's why this is uh, 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 clustering here. And potassium is actually associated with the cluster 2. So if we see the potassium, so this region is the endoganglic plain, which is well known for the biomass burning. That's why the potassium is higher. And this cluster is associated with the soil, and we know this is here is a Thar Desert and this is Arabian Desert. So these two sources is actually contributed this soil particle to the Indian continent. Yes, keep. So based on the all the potential health risk analysis, we have concluded that the exposure because of the multi-element is not is actually within the acceptable limit. So there is no any health potential health effect because of the elemental concentration based on the calculation. And similarly, we have calculated the potential cancer risk. It is also in between the acceptable limit. That's why they have a no any cancer potential cancer effect based on this concentration of element. If it is higher, then maybe there is a effect, but all the concentration are within the limit of the acceptable values for the potential cancer risk. This is comparison. Okay, so okay, I just conclude lastly. So we have characterized the PM2.5 and associated PM2.5 elements. And if we talk about the health point of view, so all the limits are within the acceptable limits. So there is no any potential health risk because of the PM2.5 over this VVNP side only. And for other region of India, we have to analyze whether these calculations are within the limit or out of the limits. If it is within the limit, then it's okay. If it is more than the accepted limit, then we have to care about and think about how to control this stress element into the atmosphere. Thank you so much.
Thank you very much, sir, for wonderful lectures on the aerosols and effect of aerosols and different variable to control this aerosols. So I am very sure that number of participants will take this area of research into the consideration definitely. Any question from the participant? Please ask. Is there any question? Please raise your hand, or you can unmute your mic and start asking. So this is studies you have done in that particular area. Have you taken this data from this Raipur area?
No, sir. This is belongs to Bhopal.
Bhopal. Okay.
During postdoc, I was conducted this study.
So one of my scholar is working on Raipur area. So is it any means have any chance to get some breakthrough because here aerosol um, means probability is very high.
Yes, sir.
and the effect and their uh, dependency of different parameters can be studied.
Yes, sir.
So, what is your point, sir?
Yes, sir. Actually, my PhD is in Raipur, and I have actually studied the Raipur city as well as one rural part, that is Rajim, to compare the PM2.5 level and PM10. So really, the concentration is too much high. Actually, even it's beyond the acceptable limit for PM10 and PM2.5. So really, it's required to conduct a study on even trace elements in this Raipur region. So yes, it's a urgently required to conduct a study and like put the implementations to control the air quality based on PM2.5, 10, and also the trace elements.
Definitely, sir. Definitely, your point will be taken into consideration, sir. So, as a session chair, I would like to thanks for Ratnesh ji is there, sir. Please, sir. Ratnesh sir, please.
Good morning.
Good morning, sir.
How are you?
बस सर आप सबको देख के बड़ा खुशी हो रहा है. It's really nicely. So
So, thank you, BIT management, for giving me this opportunity. Thank you, Dr. Kumar Swamy sir, Dr. Vikas Dubey sir, Dr. Ramarao sir, Dr. Misra sir, and all convener organizing secretary. Thank you, Dr. Jain sir. Actually, we all are colleagues. So nice to discuss with you. And when you come to India, we need some support to your side for the some chemical aspects. Actually, some people's related to chemistry part of chemistry point of view, we need some support to your side.
yes, sir, definitely, sir.
Actually,
I,
actually,
I
some of the student working in the agriculture based problem. We are going for the some new innovation and new patent work. So we need some expert related to the catalyst or some battery related new innovative ideas or some mathematical modeling also in the crystal structures and dynamics. So that is helpful for our student. If possible, let me know.
yes, sir, definitely, sir. I will try to contribute my effort to
Please
fulfill.
let us know, sir, if you are coming to India. Please
Yes, sir. Sure, sir. Will.
give a chance to you can visit our university as well
Yes, sir.
to strengthen our student and strengthen the subject and definitely this kind of collaboration should be more and more and it should be strengthened with the time. So
Yes, sir.
this is the peer group which should be ahead in future. So Dr. Ratnesh, sir,
Yeah, yeah, it's okay.
as the
Thank you.
inauguration is started, so I would like to thanks Jain
Thank
sir
you all.
for this wonderful lecture. So please join inaugural link for the
Yes, sir.
inauguration. Jain sir, thank you very much for wonderful discussion. Definitely we'll discuss further in this your particular area, and our student also discuss with you regarding some critical issues.
Yes,
Thank
sir.
you very much, sir. Thank you.
Yes, sir. Any questions or query? So there is an email ID. So please send me an email so I can reply on it in detail. And thank you so much, Kumar Swamy sir, Dubey sir, Ratnesh Joy sir, and all the participants to listening carefully and take interest on my research. And please feel free to send me email any details are required regarding the atmospheric aerosols or any area. So I try to elaborate in detail. So thank you so much for giving me the
Thank you, sir.
opportunity to share this
Thank you,
knowledge.
sir.
Okay, okay. Thank
Thank
you
you,
so
sir.
much, sir.
Thank you. Okay.
Okay.
So over to organizers. Please carry forward. So inauguration, I guess, is started. So please join the inauguration session. Okay.
हेलो हेलो आ रहा है हेलो 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 आ रहा है हेलो हेलो आ रहा है माइक ठीक एडमिट करो आ रहा था ना आवाज बोलो तो हेलो 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 आवाज आ रही आवाज आ रही हेलो 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 लाइट बंद करो सुनाई नहीं दे लाइट बंद करो तो बोलोगे हेलो 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 बैटरी डाउन हो रहा है हेलो सर सुनो एक्सटेंशन और मिलेगा हेलो नहीं है हेलो चार्ज कैसे करेंगे बंद होने वाला है हेलो हेलो माइक चेक हेलो कैमरा के लिए हेलो हेलो सब में लगा हुआ है ना 1 2 3 आइटम लगा है और क्या लगा है उसमें 4 आइटम लगा हुआ है हेलो हेलो हेलो
हेलो
हेलो सुनाई दे रहा है हेलो हेलो ठीक है
वॉइस में चेंजेस करना चाहिए। हेलो ठीक है ना हेलो ठीक है ठीक है ना
यहाँ से बोलते हैं तो यहाँ जितना भी माइक है ना जितना भी ऑन है यहाँ से सबको बंद करना पड़ेगा
और जो उसमें बोलेगा तो
वो बोलेगा उसका कोई टेंशन नहीं है
यहाँ से बोलेगा
सबको बंद होना चाहिए
Good morning, Honorable Principal Sir, Dean Academics, Dean Students' Welfare, Dean Research and Development, Dean Infrastructure, Dean Training and Placement, and Dean First Year, heads of the departments, guests from various other universities and colleges, dear students. Sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs, said Joan Harlan Burton once. No matter how complex the global problems may seem, it is we ourselves who have given rise to them. They cannot be beyond our power to resolve. And it is this attempt to mend and restore that we, the staff and students of BIT Raipur, have come up to host the third international conference on sustainable development. We have successfully hosted the second international conference pre-pandemic times, and it is our honor that ICR ESD has shown their faith on us. We need It is indeed going to be a new learning curve for the students of our college and also the distinguished faculties of each department. Together, we shall be working towards making this earth a planet it used to be. To begin with, let us seek the blessings of the goddess of knowledge and intellect. I request the convener of the conference to guide our principals and other guests for the Saraswati Vandana. Sir, please. Thank you, sir. To quote our Honorable Prime Minister, the principle of common but differentiated responsibility is the bedrock of our enterprise for a sustainable world. In few words, he has summed up what the top delegates of the so-called advanced world could not deliberate over the years. Dear guests, we don't have to engage in grand, heroic actions to participate in the change. Small acts that multiplied by billions of people can transform the world. With these, we begin our address session. Now I request Honorable Director, Sir, Dr. T. Rao, to address this virtual confluence with his scholastic words. Sir, please. Good morning, sir.
Badrinaran.
तो फिर से अनाउंस कर रहे हैं।
I request our director, Dr. Rao, sir, to bless us with his scholarship.
I am audible, sir?
Yes, sir.
Should I start? Medical sir, should I start? Medical sir, you are not audible.
Yes, sir.
Should I start?
Yes, sir.
Okay. So, good morning to all the dignitaries present over here. Honorable Principal Dr. Anup Mishra ji, Dean R.K. Mishra, Dr. R.K. Mishra, Dean Academic Abhishek Verma ji, and Dean Research and Development Sri Dr. Vikas Dubey ji, and all other deans and faculty members. So good morning to all. Good morning, honorable guests, professors, research scientists, scholars, members of the staff, and my dear students who have joined us in this virtual world. Welcome to PIT Raipur to the third international conference on recent trend in renewable energy and sustainable development 2022. A lot has changed since we had the second international conference on campus in 2020. That was the time that deadly pandemic was knocking the door of the neighboring countries. And little did we know that within few months it will take the whole world under its grip and create a global phenomenon. Millions of people have lost their life in these years, and with the grace of God, India was able to combat the disease in far better way than more other advanced nations. What is the reason? Our lifestyle, our beliefs that everything needs to be preserved and reserved. Chhattisgarh is the land rich in the natural resources, and hence it is quite relevant and justified that such a mega conference is being organized in the heart of the capital city of Chhattisgarh. The planet Earth is going through a difficult time. As you know that pandemics, global warming, unplanned use of natural and energy resources, climatic changes have made the lifestyle and life of the living beings very tough. It is in the hands of weary teachers along with the scientists and research scholars to make this country and the world a better place for the future generation. The International Conference on Recent Trends in Renewable Energy and Sustainable Development is a result of a team of forward-looking educators and of my institution. Every staff in BIT Raipur believes that through innovation and research that one can give the society back what it gives to an individual. This international conference on such a relevant topic has brought the best of the scholars from Europe, Asia, and Africa, and also from top technical institutes of India to contribute their ideas for a sustainable development. I am happy and honored to host my dear scholar friends like Dr. Latif from Belgium, Dr. Jelen from Siberia, Dr. Rath from Ethiopia, who have joined us from the thousands of kilometers to be a part of this conference. Some of the distinguished from Europe, like Dr. Martha, had a chance to be here physically in the last second conference, but now the situation is not so favorable. So we have to do away with this online mode. I once again welcome all the participants to the conference and extend my good wishes to all. Let us make this event a grand success and best wishes to all the participants. Thank you. Thank you all.
Thank you very much, sir. We are honored to have among us with the blessing Dr. Ramanujan Krishnan, principal, and under his able guidance and vision that this international conference has seen its day. I take this honor to request our Dean Students Welfare, Dr. Sankara Ma'am, to welcome our principal with a floral bouquet. We welcome this one. Trying to capture the moment. Dr. Anup Krishnan sir comes up with over an experience of 25 years with us, and he believes in working without making any fuss, silently, but his work gets into action and then we can see actually what he has vision, what he has looked forward. To listen to him, to have a welcome address, I invite him on the dais to address this conference. Sir, please.
थोड़ा पास कर लीजिए ना उन्हें राइट
Of the BIT management and staff, I take this privilege to welcome you all, BIT Raipur, to the third International Conference on Recent Trends in Renewable Energy and Sustainable Development 2022. Life Institute of Technology, Raipur, was established in the year 2009 as the second institution by the GIT Trust, State Bal Krishnan Memorial, which is dated in Government GIT Trust. I am proud to share that I am proud I have them and congratulate them and congratulate them and forward to this research and innovation. Research and innovation, the biggest tool towards the biggest part towards technical education. Faculty members have been research participated in development activity and have good research and facility in how we in this context research and development achievements are patents granted and published projects these are like cost 5,000 and project might cost of 9.5 lakhs. Paper published in SBI Focus Journal in last 9 years, 98 and others 225. Books published edited by faculty members is 3 books. So in the beginning where our clarity is so much adversities like global warming, unplanned use of methods and energy resources, climatic changes and uncertainty, vast decreases in supply of coal and other energy resources. We as scholars and academicians, along with the scientists and research scholars, have a prime responsibility to ensure that government is active with sustainable energy resources for generations to come. This international conference on recent events in renewable energy and sustainable development under the banner of ICRSSED is step towards this vision. The specific of this international conference is a confluence of great minds all across the globe. We have scholars from Europe, Asia, and Africa, and also from top technical institutions of India to share their vision on sustainable development. Our keynote speakers from various countries like Belgium, Poland, Indonesia, India, South Korea. I am also glad to see so many of our students actively participating and presenting their paper in this conference. Once again, on behalf of the entire GIT family, I am privileged to welcome you all. I am sure that these 2 days session shall bring our completely fruitful sustainable development. My best wishes to the entire conference team for grand success. Thank you.
Thank you very much, sir. It's time to invite Dr. Vikas Dubey, man behind this entire show. His research activity getting slow introduction. He is also responsible for successfully conducting the second international conference. Right now, he holds the post of Dean Research and Development. Without taking much of your time, I now invite Dr. Vikas Dubey to have his convenience service.
Thank you very much, Sir, for the invitation. So, very good morning to all. Respected dignitaries on the dais, respected Dr. T. Mahapalas, Director of the IIT, Dr. Anup Principal, Dr. Ashik Prashad, Lead Academics Director, Dr. Dr. Sangeeta Soundmati, Lead Student Dr. M.D. Nadia Sarjan sir, TPOE and Professor Santosh sir, Pasti Vasti I welcome all our co-hosts and persons, department, organic and all participants in education on state and sustainable development 2022. This is the extension of second international conference organized by the IIT in 31st January 2020 on behalf of management IIT and co-research member. I would like to welcome all key speakers participants for this occasion. The theme of the conference that achieving the solution to environmental problems that we face today requires long-term communication action for sustainable development. In this regard, renewable energy resources appears to be one of the most efficient and effective solutions. That is why there is an intimate connection between renewable energy and the sustainable development. Anticipated patterns for future energy use and concentrated environmental impacts such as focusing on acid precipitation, ozone degradation, and greenhouse effect. Potential solutions to current environment problems are identified along with the renewable energy technologies. In these 2 days, the climatic and key speakers will present their work and ideas in front of the research scholars and academics. The invited speakers from Military Institute of Technology, Poland, Dr. Jelena Matrix from Serbia, Belgrade, Dr. Latif from Belgium, Dr. Isam from University, Dr. from Ethiopia, Dr. Jen from So, we have various speakers from our institution. Our two taken up by Dr. P.R. Rudy from University of Legislative Society of India and he is working as a professor at National University of Baroda, as well as Dr. Manoj Gupta, who is a scientist at AMPI Bhopal. Now, our friend from ISB University, Dr. Anupama Swami, presented over here. He is a session chair and also invited technical in his international conference. We have received abstracts from various institutes in India and abroad. Overall, 311 accepted abstracts nearly 277. A great effort by the 3 departments like CSE, the 69, abstracts and the 63, and the academic 45. Now, some new people from the various departments such as civil, physics, civil chemical, 23, physics, 26, chemistry, 13, mathematics, 12, and communication skills. So they are taking a very good effort, and I must congratulate CSE department, Dr. Karpal, Professor Aditya Tiwari, Professor Kubi Bhatt, and CSE for their great effort, as well as from different department, Professor Rasmus Department, and Jagdeep sir, Hemant sir, and actually for their great effort. As well as from the technical department, Professor Sanjay Sahu, Dr. S.S.K. Deepak, Professor Sandeep Sahu, and actually Manish Mishra sir. And ETMB, Physics, Civil, Chemistry, Mathematics, and English departments, organizers, and co-organizers and members. Thank you very much for the great effort. Some of the quality papers are submitted to the targeted journals and published to proper review. The targeted journals are Recent Advances in Computer Science and Communication, Sir, Patent Publication Office, Poster Index Center, as well as the Medical Data Tax, Algeria Publication House. One recent issue edited by my friend Dr. Ram Sakayat from Banaras Hindu University. One journal of radiation and nuclear applications that is from Egypt. And of physics leaders, some academic books like material analysis is organic inorganic compounds from Algeria Publication House. Drinking water management that is from Deep River Publication House. This is for Civil Engineering Department. High entropy glass processing, alloy microstructure properties, deep publication for magnetic department, synthetic technology and application for energy harvesting, Nova publication house that is for engineering department. I'm really happy to management here our directors and our respected principals for the opportunity to hold such team to conduct the data. Once again, I would like to welcome all the participants. Thank you very much.
Thank you, sir. I take this opportunity to request our secretary and nominate our proceeding. I take you virtual to your just as the informed, it's over 277 that in such a short period of time, it is indeed a great number. Rather, it is indeed an effort of each and every member of the staff, head to the department, behind motivating and encouraging the students and the staff to come up with abstract and contemporary papers.
नेट निकालूंगा तो गया नेट निकालूं निकालूं चलो एचडीएमआई की एचडीएमआई अरे डायरेक्ट सर के पास ले जाओ सर कैमरा अपने पे लगा देना इसमें काम
Because of the technical glitch, there is a slight change.
वन 1816 करना है बस स्लाइड स्लाइड चेंज
कैमरा लगाओगे क्या?
अपडेट चेंज करना है बस। हाँ चेंज
दबाते रहो ना, नहीं हो रहा कुछ। हाँ हो रहा है, किसी को दिख नहीं रहा क्या?
कनेक्टेड है उसको।
Thank you. Thank you. No matter how much you talk about artificial intelligence, you will be still going to be the most happening. Thank you very much, sir. Now, I have the privilege to invite Dr. Gautam Reddy, Dean Printing Statement to address the board of trustees.
Thank you, sir. First of all, I would like to congratulate to the management and the trust, the chairman, the secretary, and secondly, I would like to specifically thank you to management of the library, principal, the commissioner, sir, all teams, all departments. I will also like to extend my special thanks to all the faculty and secretaries and the supporters of each and every department of the individual. Thank you once again, and also thanks to all the supporting staff members, those who have been and effortlessly since 3 days now preparing the best master training. Thank you one and all.
Thank you very much, sir, for your gracious presence. It's time to begin the talk. To begin the first family session, I have the privilege to invite Dr. Bhumika Kara as our secretary. Dr. Bhumika Kara is currently working as head of the Department of Minor Engineering at Max University, our research. She has completed PhD in Bauxite deposit from Punjab University. She has received Young Scientist Award in 2014 by the President Council of Science and Technology. With so much under her belt, it's a privilege that she is leading on becoming a facilitator for the third international conference on sustainable development, research and energy. Now, I invite Dr. Bhumika Kara to introduce our first honorary audience, Dr. Badrinath Rana. Ma'am, please, she is joining us on the virtual platform. Ma'am?
Yes, Am I audible, sir? Am I audible, sir? Hello? Hello?
Yes, ma'am. You are
Hello?
audible.
Okay, sir. A very warm good morning to one and all who are present here. And it is a great pleasure for me to introduce our keynote speaker today, who is going to talk to us an amazing material for. Can I start now?
You can please continue now.
Shall I start, sir? A very warm good morning to one and all who are present here. It is a great pleasure for me to introduce our keynote speaker, Dr. Badni Narayan Ras sir, who is going to talk to us about an amazing material for improving strength and durability of concrete. Dr. Badni Narayan sir, he did his PhD in structural engineering from NIT Raipur and MTech from Jalgaon University. He is right now working in 3 projects currently, and he has published several research papers in national and international journals, and he has attended several conferences, workshops, and symposium in national and international level. His ongoing project is co-principal investigator in a research and community project entitled Development of Low-Cost Cobblestone Using Partial Substitution of Plastic-Based Material. He is also working as a co-principal investigator in a community project entitled Construction and Implementation Emergency Toilet Inside the Jailhouses of East Wales Zone. He is also working as a co-principal investigator in a research project entitled Development and Application of Low-Cost Eco-Friendly Biopesticide by Using Organic Waste Material. And currently, he is working as an assistant professor in Faculty of Civil Engineering, El Volgia University, Ethiopia, from 2020. I am welcoming you, sir. Please start your session.
आंटी मैडम सर आप सच में लॉग इन करो
Sir, your mic is mute. You are not audible to us.
Now it is audible.
Yes, sir.
Now my PPT is seen to everybody.
No, sir, not visible.
Now it is visible. Presentation is visible. Hello.
No, sir.
Is it visible now?
Sir,
Hello?
not visible right now. No, sir, not now.
Oh. What happened? Screen. Now it is visible. Hello, ma'am.
Sir, it's still not visible
Is it
to
visible?
me. Yes, sir. Now it is visible.
Visible? Okay. Yes, may I start my presentation?
Yes, sir. Please go ahead.
Good morning to all of you, respected chairpersons and my friends. Now I am Badrinaran Rath from Olega University, Nekemte, Ethiopia. Now I am going to present on rubber lattice in emerging materials for the improving strength and durability of concrete. This is my contents, introduction, mechanism, experimental setup, result and discussion, and conclusions. So we know that the strength and durability of concrete depends upon the many factors. They are that is the quality of ingredients, packing density, water cement ratio, concrete compaction, curing process, and its edges, and so on. So among them, the voids and porosity, that is the two parameters which plays an important role on strength and durability of concrete. So actually the voids, it depends upon the packing density. If the packing density is more, if packing density is correct, then the voids can be reduced. And the pores are depends upon that is the how much amount of gels are produced. When the gels are produced, at that time the volume of the totally CSS gel that will be reduced. Therefore, that the pores are formed. So we know that when the waters and cements are near to each other, that time the hydration product are produced, that is the CSS gel, calcium silicate hydrate gel. That calcium silicate hydrate gel, that it reduces its volume of the actual volume of cement and waters. So when the reactions are going on, when the hydration product are forming, that time the amount of cement, the unhydrated cement that and waters, they gradually decreased, and instead of that they forms so many pores. So it is found that the main parameters of the CSS gel is one is C3S, other one is C2S. So it is found that suppose when the C3S is react with waters, then the CSS gel and calcium hydroxide, the two parameters it produces. So it is one research, it has been found out that if 228.33, that is the C3S, this is the molecular weight of the C3S, and it reacts with 95.51, that is the water, then it will be the amount of calcium silicate hydrate will be 227.51, and the calcium hydroxide will be 96.33. The density of the C3 is 3.12, and water is 1, and CSH is 1.90, and this is 2.2 for calcium hydroxide. So if the mass by volume, then the mass by density, then automatically it gives the volume. So that the volume will be 73.2 C3S, and the 95.5, it will be the volume of the water. If the 73.2 centimeter cube C3S volume will be react with 95.5 cc of the water, then the production of this CCH will be, that is CSH will be, it will be 119.7 centimeter cube, and the calcium hydroxide volume will be 43 centimeter cube. If you that is the add these two, if you add these two parameters, that is the volume of C3S, volume of waters, it comes 168.7, and if you add that is the volume of calcium hydroxide and CSS gel, it comes 162.7. Means initial volume was 168.7, and the final volume becomes 162.7. Therefore, the total difference is 6 centimeter cube. Before hydration, it was 168.7, and after hydration, it comes on 62.7. Same times in C2S case, the total difference is find out, that is the 0.4, that is 0.4% of the volume things. That means when the cement reacts with water, due to the reaction of the water with cement, the calcium silicate hydrate that will be formed, and the volume of the calcium silicate hydrate, that is the less volume than the original volume of the cement and water. So due to the sinking of the volume, this is due to the shrinkage, so many pores are formed. There are actually generally two types of pores. That is, one is gel pores, other one is capillary pores. These gel pores and capillary pores, these are the actually pores formed due to the reaction, due to the cement and water reactions, and the entrapped air, that is the air voids, that is formed due to the packing density. So the packing density is not good. That is the ratio between the coarse aggregate and fine aggregate is not proper. Then automatically the air voids will be created. So the both pores and air voids, both are the very enemies for the concrete. They reduces the strength and durability of the concrete. So the air voids, the size of the air voids generally 10 micron to 50 microns, and the capillary pores, that is the 10 nanometer to 10 microns, and the gel pore size is generally 1 nanometer to 10 nanometers. So according to that reactions and the capillary, that is the packing density, these are the three types of pores: gel pores, capillary pores, and entrapped air pores. Now, according to the formation, the two types of pores are formed. That is, one is closed pore, and the other one is open pore. The closed pore means the pores inside that concrete, and the open pore is it is one or two, one of the end or two, both of the end. They are exposed to atmosphere. This type of pore is the open pore, and this type of pore is nothing but the closed pore. Other type of pore is formed, that is the ink bottle. That ink bottle pore is, that is the initial diameter is more, but after that, just like ink bottle, the volume of that pore is more than the initial diameters. So this type of pore is nothing but the ink bottle pores. So again, the capillary pores, they are divided into three types. That is the macropores, mesopores, and micropores. A pore diameter greater than about 1 to 10 microns, that is the macropore. A pore diameter greater than about 0.1 micron to 1 micron, and micropore is a pore diameter less than about 0.01 micron to 1 micron. Then porosity, actually the porosity depends upon the composition of concrete and the casting in practices, maturing and hardening, and chemical changes due to aggressive environment. The first two parameters, composition of concrete and casting in practice, that depends upon the voids. Here are the two parameters, voids and pores. That the two main difference between the voids and pores are, the voids are, that is it is a three-dimensional parameters, three-dimensional space inside the concrete, which is larger. And the pores are, that is the very minor diameters, smaller diameters. It forms means at the time of the cement reactions. So the composition of concrete and the casting practices, that is due to this the voids are formed, and the maturing and hardening and the chemical changes due to aggressive environment, due to this the pores are formed. Now, how to measure the pore size? The measurement of pore can be taken by the radiation of scattering, vapor condensation, mercury intrusion porosimeter. In radiation scattering, the X-rays are actually incident on that surface. Therefore, when the pores are there, at that time the X-rays is deviated from its path. Therefore, the angle of deviation can be measured, and according to that angle of deviations, the pore size can be measured. In vapor condensations, that is the vapors are provided, and when there is a pore that will be absorbed, the amount of absorbing the vapors, that will give the size of pore, that is the size of the pores, diameter of the pores. But the these two processes are little bit very difficult, and therefore people are generally taking the lab in laboratory experiment is by mercury intrusion porosimeter. The mercury intrusion porosimeter, it is in this lab setup, the accurate diameters of the pores and the percentage of pores can be identified. So in that mercury porosimeter, the mercury is used here. It is a one cylinder. In that cylinder, the mercuries are kept, and the mercuries are injected to the samples. Here the two slots are there. In that first slot, the total containers and that is the samples, they are first evacuated, and after that, the second slots, that is the mercuries are injected at a high pressures. So the ability of these pore diameters is 0.03 to 360 microns. And this maximum pressure is applying in this mercury intrusion porosimeter is the 400 MPa. So if 1 atmospheric pressure that fills the 12 micron diapores, and if the 400 MPa pressure it gives, it fills the 3 nanometer diameter pores. Actually, the mercury intrusion porosimeter, it works on the Washburn equation, P equal to 4 gamma cos theta upon D. When we know how much pressure we are implementing, that pressure we know, and gamma is that is surface tension. So for these two parameters, that is mercury surface tension we know, and the pressure we have known, we can measure. Therefore, from these two parameters, we can find out what is the diameter of the pores, which it can be easily find out. Why the mercury is used here? Because mercury is that it is a non-reacting materials, and it is a non-wetting. If you use the water, then automatically the pores will be absorb the water. So how much amount of volume will be occupied by the space of the pores, it cannot be measured. Therefore, in these conditions, the mercury is used for as a measuring materials. So the MIP is measured the pore size and not the actual pore size. This is due to the phenomenon known as the ink bottle effects. In ink bottle effects, that is the diameter is known, but after that this squeeze diameter, the volume of that pores will be increased. Therefore, the exact volume cannot be determined by the MIP to the ink bottle size pores. In older penetrometer, that is the intrude volume was directly measured using the scale of the tube, but this made it impossible at a high pressure. In modern instruments, the capacities of the cell is measured and converted to its volume. Means how much amount of that mercury is consumed through the pressures that is measured, and due to the consumption of the consumption of the volume of the mercury, that the exact diameters of the pores it can be identified. So that is to reduce the porosity. So many researchers they have used, that is the supplementary cementitious materials, the crystalline admixtures, fibers. There is so many materials we can use in concrete, and we can reduce the porosity of the concrete. But in supplementary cementitious material, that is not available in every corner of the world, and the transportation of this SCM to remote areas may be difficult, and it will be highly expensive. So in actually this the fly ash, slag, silica fume, they are actually generally produced in our India, because in India it depends upon the thermal power plants. But in our Ethiopia, any other developed countries, they are generally depends upon the that is the nuclear power plants. So the fly ash, pond ash, slag, this type of supplementary cementitious material, it is not easily available in these countries, and transportation of cost also too much more. When that is everywhere that the factory will not be established. Therefore, the transportation of material is a very costly process to transport the supplementary cementitious material from one part of the country to other part of the country. And people are used for the crystalline admixtures. The crystalline are in chemical nature, and they are maybe hazardous, and they may be highly expensive, and it cannot be used more than 2% in concrete. People are using also fibers. The fibers, that is it is a non-reactive cementitious material, and it arrests the shrinkage cracks. But due to it cannot be used as a excessive amount, or it cannot be used from a certain limit, because if you use more amount of fiber, then automatically fiber lumping will come. Automatically the workability will be of the concrete, that will be hampered, and the voids will be creates. And it also an expensive material. Therefore, the using of the fibers in concrete, it will increase the cost of the constructions. So according to so there is a means alternative one resource material. It should be sourced so that the porosity or voids of the concrete that can be reduced, and it should not be increase the cost of constructions. It should be naturally available, and it should not give any byproducts due to the reactions. So for these conditions, we have selected the rubber lattice. This is a rubber lattice is an amazing material. It is collected from the rubber tree in liquid form. The liquid rubber lattice can mix with water homogeneously and also easily mix with the concrete. The micropores of the concrete are filled with rubber lattice at the time of mixing. After some time, it loses its plasticity, becomes solid, and seal the voids fully. In our India, that is in Kerala and Tripura, these two states, they have a large number of production of the rubbers. The environment is very suitable to rubber plantations. When I was in Ikphai, Tripura, so at that time this research I have started. So I found that the rubber lattice is one type of materials. It when we are collecting from the trees, it is in liquid form. This is in this way the people, they are collecting the rubber lattice from the plants. So when it comes from the tree, it is a liquid form. But after 7 to 8 hours, it starts losing its plasticity, and it becomes a little bit solid. So due to the liquidity, due to the means liquid state at the time of initial at the time of the collections, so it can be easily used in the concrete. It can be easily mixed with concrete. So when it mixed with concrete homogeneously, after some time it loses its plasticity, and the voids and pores, it can be easily filled by this rubber lattice. Suppose if you see the properties of the rubber lattice, its specific gravity is 1.04. The specific gravity is water is 1, and its rubber lattice specific gravity is 1.04. That means this is nearby to water specific gravity. Therefore, it can easily soluble with waters, and it can be easily mixed with the concrete. Its pH is 8.1. Means 8.1 means it is alkalinity. So due to it is greater than the 7. Therefore, it cannot means react with any acid elements. Therefore, it cannot form the byproducts due to the alkalinity character. Therefore, the pH value of the concrete that remains, because we require the pH of the concrete should be more than 12. Therefore, due to the alkalinity, there is no acid alkalinity reactions. Therefore, no byproducts will be formed due to the mixing of the rubber lattice in the concrete. Its total solid content is 62.48%, and volatile fatty acids is 0.015% due to the volatile fatty acids. Therefore, it will be it is workable. It increases the workability of the concrete. So many people, they have used the synthetic rubber lattice. So these are the Diab et al. The 5 types of synthetic rubber lattice, and other people, they are used the acrylic, polyvinyl acetate, carboxylic styrene, vinyl chloride, or styrene acrylic latex. So among these lattice, you can see that the average particle size is too much more. But in natural rubber lattice, the average particle size is 0.1. Therefore, due to the microparticles, it can easily fill the voids of the cement particle in between the cement particles and the aggregate particles. So for this research, we have prepared two types of the concrete. One is traditional cement concrete, other one is geopolymer concrete of M40 grade. And in traditional cement concrete, we are replace the water by rubber lattice 0 to 2%, and in the geopolymer concrete also we are replace the waters from 0 to 2% by rubber lattice. And then these are the ingredients for preparing the traditional concrete and the geopolymer concrete. For the traditional concrete, we are using the cement, but as a cementitious material. But in geopolymer concrete, the calcined clay is used. Here the aggregates are two types of aggregates are used. One is brick aggregate, and one is coarse aggregate. Actually, the brick aggregate is used for the internal curing. Actually, this project was started at the ICFAI Tripura because in Tripura state, very difficult to get the coarse aggregate. In Tripura state, all of the peoples, maximum peoples, they are using the brick aggregate. That is one of my scholar. He is doing PhD in ICFAI Tripura. So he has collected all these materials and he has started these experiments. And the data I am using in this research and in these presentations. So after using the rubber lattice, it is found that the slump height also increased in both traditional concrete and the geopolymer concrete. In geopolymer concrete, that is it generally the workability is very less in geopolymer concrete than the traditional concrete. So this rubber lattice is a very a good material. It is a suitable material to increase the workability of the
all So for the P percentage, it can be written as 1 minus D minus WS upon rho upon VT into 100. And the porosity can be determined by that is the VS upon VB upon VS, and also it can be determined by the we have known. So if you put these parameters, ultimately the porosity of the concrete that can be determined.
So here what is we done? We taken a water tub and inside the water tub we dipped that concrete cubes. So the concrete cubes when are dipping in one part, suppose in this way, so the bottom portion cannot be means totally contact to waters. Therefore, because when we deep inside the when a cube is deep inside the water, then automatically the hydrostatic pressure will be act in this way. So at the top most portion the hydrostatic pressure is very less, and the bottom of the cube the hydrostatic pressure is high. So there is no equal hydrostatic pressure. Therefore, automatically the amount of water, it cannot same amount of water cannot be poured on the all parts of the face. And when it is deep inside the water, automatically the bottom part is not it is not included by the water volumes. So what happened?
Sorry to interrupt you, sir. You have only 5 minutes to conclude your presentation.
Yes, ma'am. So in these conditions, so we just first put the cubes, and every 30 minutes it's rotate in suppose it is XY plane, YZ plane, and ZX plane. In 3 planes it is rotated, and the how much amount of that voids are sealed, it is again measured. So it found that when in first tapping process, the traditional concrete has, that is the 21.78% porosity, and the 2% rubber lattice is used, it is 14.23%. It is the porosity becomes 0.58%, and here in traditional it was 1.24%. When the second tapping, it is found as the for the 2% rubber lattice, it is very minimum, and than the traditional concrete. And so the conclusions, the following conclusions can be drawn from the present research. It is found that the total voids of traditional concrete mix are more than the different mixes of geopolymer concrete by replacing water with rubber lattice at various percentages. That is Mg0, Mg.5, Mg1, Mg1.5, Mg2. But the micropores of the geopolymer concrete are slightly more than the traditional concrete due to the fine particles of calcined clay. Replacing water with rubber lattice up to 2%, the reduction of the porosity of geopolymer concrete was recorded as 50% by mercury intrusion porosimeter test, 33% by water displacement test. Due to addition of rubber lattice, the micropores were sealed fully after hardening, and the micropores were partially sealed and converted into mesopores. When the dose of rubber lattice increased up to 2%, the threshold diameter changed to 10 nanometer from the 30 nanometer. Since the rubber lattice is easily available and gets mixed homogeneously with water, it can be recommended for using rubber lattice in concrete instead of water. Since rubber lattice can mix easily with concrete ingredients, mold in any shape can seal all the pores inside the concrete after hardening and provides better strength and durability to concrete structures. It is strongly recommended that more than 2% of rubber lattice should be replaced of water for health improvement concrete. If the rubber plantation will encourage local farmers, then the price of rubber lattice will be very less as compared to chemical admixtures. Generally, the chemical admixtures are hazardous, highly expensive, and cannot be used more than 2% cementitious materials. But natural rubber lattice is purely organic, non-toxic, less priced than admixture, and can be used at a high percentage. Also, rubber plantation will increase the greenery of the environment. And using this experiment, that is in up to 5 papers in Scopus Index journals, it is published. That is 3 have been Springers, and 1 is the other one is Thai journals. So thank you very much. Any suggestion to improve my presentation are welcomes. Thank you very much, ma'am.
Thank you so much, sir, for taking time from your busy schedule to be the part as a guest speaker at international conference. And all thanks to your very informative and enlightening presentation. I'm sure everyone have got to know a lot from this presentation. Thank you so much. If anyone have any question, please ask.
Okay, thank you, ma'am. Thank you very much.
Thank you so much, sir. Thank you.
Okay, thank you.
Now, I'm glad to welcome to our second keynote speaker, Dr. S.P. Mishra, sir, who is going to talk about capitalizing the opportunities in engineering technology, management, and rehabilitation of built environment. Dr. Mishra, sir, currently working as a principal in Government Polytechnic College, Ramanujganj. He's also worked in BIT Durg as a professor in civil engineering department from 2000 to 2016 and also worked as a professor and head of civil engineering department of technical education, Government Polytechnic College Dhamtari from 2016 to 2019. He has several licenses and certifications and he has a life membership of Indian Concrete Institute, AITPI Institute of Town and Planning India and Institute of Engineering. Sir, please share your screen. Dr. S.P. Mishra, sir. Dr. S.P. Mishra, sir, am I audible to you? Okay, he will join soon.
Ma'am, he is joining in a while.
Okay, sir.
Yes, ma'am.
Dr. S.P. Mishra, sir.
Yes, I have joined
Good
now.
morning, sir. Yeah, good morning, sir. Welcome to this technical session. Please share your screen, sir.
Okay. Everybody is listening. क्या मैं ऑडिबल हूँ? हेलो?
Yes, sir. Yes, sir.
हाँ. थैंक यू. आप लोग को बहुत बहुत बधाई हो कि आपके यहाँ बीआईटी मैनेजमेंट ने एक इंटरनेशनल कॉन्फ्रेंस रखा है और सिविल इंजीनियरिंग में भी हम लोग आज शेयर करने के लिए मौका मिला है हम लोग को. ये बहुत अच्छी बात है. Thank you for the organizers also. And
who is going to talk about capitalizing the opportunity to in engineering technology management Dr. S.C. Mishra, sir, currently working as a principal in Government Polytechnic College, Ramanujan, IIT Raipur, in civil engineering as a professor in civil engineering from 2000 to 2016, and also worked as a professor and head of department of civil engineering in Government Polytechnic College, Dhamtari. He has several licenses and certifications. He is also having life membership in Indian Concrete Institute, Institute of Town Planners in India, and Institute of Engineering. Thank you so much, sir, for joining us today. Please share your screen.
Okay, thank you. Whether my voice is clear and audible to all?
Yes, sir, audible.
Yes, sir. Anybody can listen properly?
Yes, sir.
Okay. Yes, sir. Nice. And what is the strength of gathering today?
Sir, more than 90.
More than?
Sir, approx
90. 100.
Approx 100. Very good. And this gathering is distributed from second year to final year and MTech also? The students category is from second year to final year and MTech also? Hello?
Yes, sir.
क्या मेरी आवाज सुनाई दे रही है? मेरे को तो ऐसा लग रहा है कि थोड़ा गैप हो जा रहा है.
No, sir, you are audible.
Okay. Should I start now?
Yes, sir, sure, sir.
Sir, you are clearly audible.
हाँ, मेरा प्रेजेंटेशन दिख रहा है आप लोग को?
Yes, sir, visible है.
ओके, ये जो टॉपिक
Yes,
है
sir.
मेरा वेरिड फील्ड है ना, कंक्रीट टेक्नोलॉजी, कंस्ट्रक्शन मैनेजमेंट, स्ट्रक्चर्स, काफी मतलब वेरिड फील्ड है. लेकिन मैंने आज के लिए थोड़ा सा एक नया टॉपिक चूज किया है और ये सोच के चूज किया है कि हम इसको आगे डिस्कस कर लेंगे क्यों चूज किया है. यही चूज किया है, इसलिए चूज किया है कि हम लोग सिविल इंजीनियरिंग के बारे में जितना पढ़ते हैं उतना ही सिविल इंजीनियरिंग नहीं है, उससे बियॉन्ड है और बहुत ज्यादा है. और एक थोड़ा सा एक बच्चों को हम एक व्यू देना चाहते हैं और ये देना चाहते हैं कि उनकी अपॉर्चुनिटीज भी बहुत ज्यादा है, लिमिटेड नहीं है. चलिए, the topic is capitalizing the opportunities in engineering, technology, management and rehabilitation of built environment. We are going to discuss about the various facets of civil engineering, and how we are teaching civil engineering is also discussed here. Capitalizing the opportunities, ये अगर आप वर्ड मीनिंग में जाएंगे तो capitalize is to put something in capital letters. तो opportunities we are going to discuss in capital. And to capitalize also means to take advantage of a situation. When we take advantage of a situation, we want to improve the capitalized cost. One thing is we discuss in capitalized cost in quantity survey. Students and teachers know that quantity survey में हम valuation में हम discuss करते हैं कि capitalized cost, capitalized value. तो हम वहाँ ये देखते हैं कि यदि कोई बिल्डिंग अगर हमें X अमाउंट दे रही है, हमारा अगर उसका रिटर्न, तो हम उसकी वैल्यू कैसे निकालेंगे? अगर हम रेंट के रूप में अगर X अमाउंट पर वी आर फेचिंग X अमाउंट, तो हम उसकी वैल्यू ऑफ द बिल्डिंग हम कैसे निकालेंगे? वैसे ही हम सिविल इंजीनियरिंग की वैल्यू या उसको हम कैपिटलाइज करने की कोशिश कर रहे हैं. Ways to capitalize on growth opportunities. Here we are talking about identify what your customer values. हमको ये आइडेंटिफाई करना है कि हम सिविल इंजीनियरिंग पढ़ के अल्टीमेटली जॉब मार्केट या बिजनेस मार्केट में उतरते हैं, तो हमको ये समझना है कि हमारे कस्टमर्स क्या चीज वैल्यू करते हैं. Stay attuned to the market. When we are studying in civil engineering, we should be attuned to the need, then start small. Whatever the specialization we take at the MTech, or whatever we do in the engineering, we study in the engineering BE, it is a start small and then prepare financially for next level business or learning. हम यहाँ पर उसके बाद हम next level की learning की बात करते हैं. These words are taken from the economics. Okay. Here we are going to discuss that what is the advantage of this presentation. We are going to value addition of our education, scope of employability and scoring knowledge, focusing engineering applied to field, selecting higher education. These are the major places where we are going to have advantage of this presentation. Introduction. आप जस्ट गो थ्रू हो जाइए. ये जो इंट्रोडक्शन लिखा गया है, ये दिस प्रेजेंटेशन एम्स टू फोकस नीड फॉर एजुकेशन चॉइस, हम क्या पढ़ाएं या पढ़ें, एंड स्टूडेंट्स एटीट्यूड इन रिलेशन टू सिविल इंजीनियरिंग टेक्नोलॉजी. स्टूडेंट्स का एटीट्यूड क्या होना चाहिए सिविल इंजीनियरिंग टेक्नोलॉजी को लर्न करने के लिए. It has been evident that the students opting civil engineering in their first year BTech end up their interest in civil engineering with the various competitive exams. वो भूल जाते हैं कि वो सिविल इंजीनियरिंग लिया था उन्होंने बिल्डिंग या बड़ी बड़ी स्ट्रक्चर्स बनाने के लिए, वो भूल जाते हैं एंड they join to the various coachings and forget about the classes, forget about the teacher and everything, and they are mostly they forget about the civil engineering aspects. Approximately out of all, hardly 20% of students choose construction engineering and technology. ये मैंने ज़्यादा ही बताया है. ये 20% भी चूज नहीं करते हैं. जब B करके निकलते हैं तो 20% भी चूज नहीं करते हैं as their career. 80% search jobs in various government sectors, PSU, PSC, UPSC, but out of them, only maximum 10% of students get success in their competitive exams. Is it true? Is it true? This estimation is true? Hello?
Yes, sir.
10% जो स्टूडेंट्स हैं वो कॉम्पिटिटिव एग्जाम्स के लिए तैयारी करते हैं और 10% स्टूडेंट्स दे गेट सक्सेस. आई एम नॉट डिस्करेजिंग एनीबॉडी, but the scenario is what I have observed when I was teaching in BIT Durg, and I have seen many universities and colleges. People forget the civil engineering, they start about the competitive exams, and ultimately only maximum of 10% they get selected in the government jobs. I'm talking about the first year, first few years की बात कर रहा हूँ मैं. Competitive exams, and later on most of the students forced to go to the construction field without any knowledge.
Sir, your slide is not changing.
Hello?
Your slide is not changing.
What is the introduction? Are you
No. It is only first slide.
Now? Abhi?
No, sir.
No, sir.
It is not changing.
What should I do now? Escape.
Sir, can you put it in presentation mode so that it will be easy?
Presentation mode. Tell me where it is.
F5 दबाइए सिर्फ.
Yeah?
F5.
F5.
Yeah.
कुछ दिख रहा है?
No.
Now it is on introduction.
Okay. Means अगर मैं change करूँ, अगर मैं change करता हूँ, suppose.
Yes, sir. It is changing.
Okay. Now it is the first slide of introduction. And I'll proceed with this, and I'll start presentation from here. Okay? Is it okay?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Proceed, sir.
Now I'm talking about that approximately out of all students, it is my observation, and it is a very serious observation. Please note, all students and faculty, please note this, where we are heading. Hardly 20% students choose construction engineering technology as their career. When I'm talking about construction engineering technology, means they are going into the mother field of civil engineering. And 80% choose for the competitive exams. And mostly they are government of PSU or UPSC or PSC. And it is so tough competition is there that hardly 10% of the students get success in those competitive exams. मैं ये नहीं बोल रहा हूँ कि वो लाइफ लॉन्ग अगर मेहनत करेंगे तो नहीं हो जाएगा, बट फर्स्ट 2 years की बात करूँ मैं तो 10% of the students get success in these competitive exams, and later on most of the students forced to go in the construction field क्योंकि उनको अपने ब्रेड एंड बटर की जरूरत होती है, उनको कमाने की जरूरत होती है. विदाउट और मिनिमल इंटरेस्ट, उनका कोई इंटरेस्ट नहीं होता है सिविल इंजीनियरिंग में, लेकिन बट दे आर फोर्स्ड टू गो टू ऑन. Some of them explores other fields like software development or management field, MBA, etc. They go for that field. Now it is changing. The slide is changed.
Sir.
No, sir.
Huh?
Sir, not changing.
Not changing.
सर लेफ्ट कॉर्नर में एक प्रेजेंटेशन का ये है, उसमें आप क्लिक करके
एक मिनट, लेफ्ट कॉर्नर में प्रेजेंटेशन.
सर सेव बटन है, अंडू है, उसके बाद प्रेजेंटेशन है ऊपर में, सबसे ऊपर ऊपर उसके भी ऊपर सर.
ये अच्छा, इसमें अपन देख रहे हैं ना, इग्नोर. This is so everyone chat. This is what activities में है क्या?
प्रेजेंटेशन स्लाइड में ऊपर में यहाँ पे कैपिटलाइजेशन वर्ड लिखा है, उसके जस्ट लेफ्ट में एक प्रेजेंटेशन का मोड है ऑरेंज कलर की इसमें स्क्रीन में.
ये वाला?
हाँ.
अभी ठीक है? अभी क्या दिख रहा है आपको?
नहीं आ रहा सर.
सर इंट्रोडक्शन स्लाइड ही विजिबल हो रही है अभी तक.
कुछ दिखा, चेंज हुआ?
नॉट चेंजिंग सर.
सर ये नीचे में 41% के बाजू में एक प्रेजेंटेशन का है, उसमें कर लीजिए, राइट साइड टॉप कॉर्नर में
41%.
उसके बाजू में सर देखिए प्रेजेंटेशन का एक है, नीचे सर.
जहाँ जूम इन आउट करते हैं, जहाँ से जूम करते हैं सर, उसके बगल में
जूम करते हैं हम स्लाइड उस पे. सर नोट्स कमेंट्स.
एक्सक्यूज मी सर उसको फुल स्क्रीन कर दीजिए सर. पीपीटी फुल स्क्रीन.
पीपीटी फुल स्क्रीन
फ्रॉम करंट स्लाइड.
Start from beginning. Record, rehearsal, hide.
Yes sir, current slide.
Current slide. ये तो मेरे को तो फुल स्क्रीन दिखा रहा है. वहां आ रहा है कि नहीं?
नो सर.
नो सर.
कस्टम.
सर एक बार अनशेयर करके शेयर कीजिए.
हाँ?
F5 बनाइए, अनशेयर करके शेयर कीजिए सर एक बार.
अनशेयर करके शेयर करते हैं, ये बात ठीक है. स्टॉप शेयरिंग. नाउ प्रेजेंट नाउ ना, एंटायर स्क्रीन करूं क्या?
सर दैट विल बी बेटर अगर आप वैसा कर पाए तो.
Share. It is not I mean share your entire screen. No one wants to share the contents of your screen to meet the Google.
सुनिए
अभी आ रहे हैं स्क्रीन?
सर स्क्रीन आ रहा है अभी भी, स्पेलिंग वाला जो उसमें लिखा है उसमें क्लोज कर दीजिए।
कौन सा वाला?
सर जो स्क्रीन दिख रहा है उसमें स्पेलिंग करके लिख के आ रहा है राइट साइड में।
अभी चेंज हो रहा है क्या?
नहीं हो रहा सर।
नो सर।
चेंज हो रहा है?
नो सर।
क्या प्रॉब्लम है? Anybody can guide me how to change it?
फिर से एक बार कीजिए, अभी हो रहा था सर।
हाँ,
अभी एक बार फिर से कीजिए।
फिर से स्टॉप शेयरिंग करूं?
एक्सक्यूज मी सर।
हाँ
सर एंटायर स्क्रीन सेलेक्ट करिए, जब स्क्रीन शेयर किए हैं
हाँ,
प्लीज सेलेक्ट एंटायर स्क्रीन।
मगर वो तो उसमें ऑप्शन ही नहीं दिखा रहा था। मैं तो एंटायर स्क्रीन सेलेक्ट किया हूँ, ये ऐसा आ रहा है। शेयर अभी दिख रहा है
आपकी
स्क्रीन? यस सर, इट इज प्रेजेंटिंग।
सर भी प्रेजेंटेशन ओपन कीजिए।
अभी दिख रहा है?
हाँ यस सर, इट इज विजिबल।
नाउ इट इज चेंजिंग।
यस सर, चेंजिंग।
Yes,
It
sir.
is
Changing.
It is second slide. It is third. It is fourth where we have
Yes.
discussed.
Yes sir.
It
Yes
is fifth.
Yes sir।
The introduction we are discussing, but somehow if the students are properly oriented, now we are the solution. But somehow if the students are properly oriented, oriented means who will orient the student? Either they themselves or the teacher or the university or the management or the government, whoever is can contribute. Best is the person himself. But somehow if the students are properly oriented, a mass employability is available in the field of development and knowledge of new material technology, construction software, construction technology, construction techniques, construction equipments, technology of rehabilitation of structures, non-destructive technology, cost and time overrun of the projects in the field of civil engineering technology. Therefore, this paper capitalizes the opportunity in major job-oriented fields, learning options, and higher education in the field of built environment. We are talking not only for the job, we are talking about the learning options after BTech and beyond that also, and higher education in the field of built environment. When I'm choosing a word of built environment, means whatever we build, from airport to railway to buildings to all the public properties, private properties, everything. This is, we are talking about the built environment. Civil engineering. Now we are talking about civil engineering. What is civil engineering? We know very much. Why we have put here civil engineering? Because after this there is a slide called engineering and engineering technology. So to discuss this, in major we study about structural designing of buildings, steel structures, bridge pavements, railway pavements, irrigation structure, etc. And basic science applied to materials. ये हम लोग डिस्कस करते हैं सिविल इंजीनियरिंग में। हम लोग डिस्कस करते हैं मोस्टली स्ट्रक्चरल डिजाइन के बारे में, बिल्डिंग डिजाइन पर। अगर आप फर्स्ट ईयर से लेके फाइनल ईयर तक, सेकंड ईयर से लेके फाइनल ईयर तक के पूरा सिलेबस देखें तो ये कहीं ना कहीं बस डिजाइनिंग की बात करता है मोस्टली वहाँ डिजाइनिंग, स्ट्रक्चरल डिजाइनिंग, डिजाइनिंग ऑफ पेमेंट, डिजाइनिंग ऑफ दिस डिजाइनिंग. But we are this is the engineering where only some basic concept of science is applied. This is method of engineering. Now we talk about the engineering and versus engineering technology. Technology is made by being oriented, while engineering, these words I have taken from the internet. What is the meaning of technology? Technology, we mostly get confused. What is engineering and what is technology? Technology is made by being action oriented, while engineering is done by being knowledgeable. हम knowledgeable होते हैं कुछ हम research करने के लिए कुछ but here it is action oriented. Technology is action oriented. Technology is the produce that is formed after engineering. Engineering होने के बाद उसकी technology होती है और उसके ऊपर चीजें बनती हैं. Technology can be used for a countless number of times, whereas engineering takes time to be perfect. अपने आप को परफेक्ट करने के लिए इंजीनियरिंग को काफी समय होता है, बहुत सारी थ्योरीज बनती हैं और एक चीज इंजीनियरिंग की चीजें डेवलप होती हैं. और हम जैसे ब्रिज डिजाइनिंग करना है तो एक मेथड हम डेवलप कर पाते हैं. बट टेक्नोलॉजी कैन बी यूज्ड फॉर a countless of times. There are more opportunity for career in technology than engineering. This is my focus point. Construction engineering technology. In major, it deals with engineering technology applied to construction of structures such as normal to high-rise buildings, skyscrapers. Skyscrapers means it is assumed that the buildings are scraping the sky. Such high-rise buildings means 1 kilometer high building, 2 kilometer high building, 5 kilometer high building. In future, you will see it. Pavements, water resource, structure, and all kind of modern built environment. So this is construction of that. New technology in construction for cost and time reduction and improved quality with minimization of human energy. हम नए टेक्नोलॉजी को इसमें इंट्रोड्यूस करते हैं और यहाँ पर हम इम्प्रूव्ड क्वालिटी की बात करते हैं, फास्ट वर्क की बात करते हैं, मिनिमाइजेशन ऑफ ह्यूमन एनर्जी की बात करते हैं, क्रिएटिंग चॉइसेस ऑफ न्यू डिजाइन की बात करते हैं, शेप्स हम चेंज करते हैं बिल्डिंग की और सेफ्टी का ध्यान रखते हैं. दिस इज व्हाट वी आर डूइंग इन कंस्ट्रक्शन इंजीनियरिंग. इफ वी कंपेयर कॉन्सेप्चुअल प्रोपोर्शनिंग यदि हम करें, मेरा स्लाइड दिख रहा है आप लोग को ना? हेलो?
Yes, sir, visible.
Okay, thank you. Then this is the conceptual proportioning. Conceptual proportioning, I am bringing civil engineering in comparison to the construction engineering and technology. Here we can say civil engineering technology also. Isme what we study is you can see the ingredient that material engineering we discuss 5%. We are talking about a broad field of construction and civil engineering technology, where civil engineering we are discussing 5%, and in construction engineering it is discussed 10%. डिजाइन हम सेकेंड ईयर से लेके फाइनल ईयर तक सिर्फ डिजाइन करते हैं. बच्चे डरते हैं, डिजाइन से भाग जाते हैं और उसका कोई यूज नहीं होता है. डिजाइन करने वाली पूरे इंडिया में 2-3 फर्म होती हैं जो पूरे इंडिया को रूल करती हैं. तो we design, we teach students, our students 60% of the syllabus is being discussed about the design, whereas in construction engineering it is just given 20% of introduction part, 20% of the design part. Sciences we use mostly in civil engineering 20%. Maths भी उसमें आता है. तो sciences we use 20% and construction engineering में we use 10%. Only applicable, everything is not required. Only applicable things are we are going to discuss. Construction engineering. Construction engineering is at 10% in civil engineering, whereas in construction engineering technology it is 40%. We talk about the construction technology, construction equipment, construction management, construction process, everything. But here it is limited to 10%. Construction management. We talk about construction management in civil engineering, 5%, whereas in the construction engineering technology, it is 20%. This is a conceptual proportioning. You will not, I'm not claiming that it is proved by mathematical and everything. It is not that in that way. It is the practical observation which you can also see the syllabus and understand. Construction technology. Those who want career in profession of construction of structures, उनके लिए है. Profession of construction of structures approached in design, production, maintenance, and disposal of a structure. Framework of its understanding. And now we are talking about how the process and knowledge is being developed. This is the process of choice. Which kind of building will be, what will be the shape, what will be the design. This is the process. And process is how the process is found. It comes from the evaluation of various requirements and its suggestion from various experts. This is the choice we develop for a particular thing. Now we talk about the knowledge required. Knowledge required in construction process is it is a dynamic. It is a dynamic systems. It is a dynamic system. It is a dynamic system, and it is okay. It is construction detailing. This is how we develop the choice of process of choice and knowledge required. Then it is framework of analysis, physical and social context, design concept, construction concept. Construction concept comes from the resource base. Then managing construction process. Construction process is the knowledge of construction process to learn is section 1. In section 1, it is covered in this. Section 2, estimating detail. These are the things which it is covered. Section 3, scheduling. Section 4, fundamentals of project control. Managing construction process. Here it says that 98% of the projects incur cost overruns. जितने भी प्रोजेक्ट हैं उसमें से 98% प्रोजेक्ट हैं जो कॉस्ट ओवररन होते हैं. तो इसके लिए we have to prepare for our students. Okay. So this is I think is there any shortage of time? Hello?
Yes, sir.
Is there any time allotted? How much time is remaining for me?
Sir, 10 minutes.
Really?
Yeah, yes, sir.
Okay, I'll finish it up in 5-7 minutes.
Okay, sir.
Okay. तो मैनेजिंग कंस्ट्रक्शन प्रोसेस है जिसके बारे में मैं चाहूंगा कि स्टूडेंट्स जाने समझें. ये अपने आप में एक एक चीज जो एक एक स्लाइड में एक पॉइंट लिखी गई है ये अपने आप में एक कैरियर हो सकता है ना. हम सिर्फ वो सिविल इंजीनियरिंग जो बी के लेवल में पढ़ते हैं उससे हम समझते हैं कि वो हमारा दिस इज वेरी ब्रॉड लेवल में हम पढ़ते हैं. वेयरएज यहाँ एक एक चीज कॉस्ट इंजीनियरिंग, कॉस्ट शेड्यूलिंग, labor and equipment studies, cash flow analysis, it can be a lifelong career. Then comes the rehabilitation. जब हम बिल्डिंग बना लिए सब कुछ हो गया तो अभी जो कैरियर जो सबसे ज्यादा कैरियर पॉसिबिलिटीज हैं वो है रिहेबिलिटेशन में. क्योंकि किसी भी समय में जितनी भी बिल्डिंग्स बनी होती हैं वो करीब 80% तक होती हैं और 20% ही बनती होती हैं. तो जो 80% बनी हुई बिल्डिंग उनके मेंटेनेंस में बहुत सारे इश्यूज रहते हैं और उसके लिए एक्सपर्ट्स नहीं है हमारे पास. तो यहाँ हमारे को इसमें अपने एबिलिटी को इंक्रीज करने का जरूरत है. उसमें नॉन डिस्ट्रक्टिव टेस्टिंग बहुत बड़ा चीज है. देन रेट्रोफिटिंग मेथड्स एंड मेथड्स ऑफ कैसे हम किसी एक बड़े से स्ट्रक्चर में जो कि एक डैम हो और उसमें करोजन आ गया वो स्टील में तो हाउ वी कैन रिमूव द करोजन विद केमिकल प्रोसेस दैट इज नोन द कैथोडिक प्रोटेक्शन. ये ऐसी बहुत सारी टेक्नोलॉजी है जिसमें हम बिल्डिंग को बचा सकते हैं, उसकी लाइफ इंप्रूव कर सकते हैं. वी कैन रिड्यूस द स्टोरीज है ना. अगर कोई बिल्डिंग अगर बहुत ज्यादा डैमेज हो गई हो तो उस बिल्डिंग को हम रिहेबिलिटेट कैसे कर सकते हैं, फाउंडेशन रिपेयर कर सकते हैं, फाइबर रैप टेक्निक है, कंक्रीट जैकेटिंग है. Okay, this is how I am finishing this topic. It is a very big thing. Many things we wanted to discuss, and I think at least introduction of my the masses must have reached how we should change the aspect, because if you ask a student, then he is taking civil engineering to become a civil engineer, but he is ending his life on competitive exams, and ultimately he left civil engineering. So this is a serious issue we should take up. Hello. Hello.
Please accept our thanks for a great presentation. Thank you for taking time from your busy schedule to be the part of this session. Thank you so much, sir. Thank you.
Thank you. Thank you. Thank you all.
From student section, if anyone having a doubt, please ask.
Sir.
Yeah.
सर मटेरियल इंजीनियरिंग के बारे में थोड़ा बताएंगे सर, क्या है,
क्या आप जानना चाहते हैं उसमें?
सर मटेरियल से क्या समझे अपन, क्या होता है, थोड़ा सा बता दीजिए.
मैटेरियल जो भी कंस्ट्रक्शन होता है उसमें अगर आप देखेंगे तो अबाउट हम लेते हैं कि 70% इज द कॉस्ट ऑफ मटेरियल एंड 30% इज द कॉस्ट ऑफ लेबर, टेक्नोलॉजी एंड मशीन्स. तो 70% तो उसमें मटेरियल होता है. तो अगर कॉस्ट को हम कंट्रोल करना चाहते हैं, बेटर बिल्डिंग बनाना चाहते हैं, बेटर स्ट्रक्चर बनाना चाहते हैं, तो हमें नॉलेज होना चाहिए मटेरियल्स का. और मटेरियल्स अगर 10 जगह से मटेरियल आया है तो उसमें हमको नॉलेज होना चाहिए कि मटेरियल को हम कैसे टेस्ट करें कि 10 लोगों में से कौन सा अच्छा है. दिस इज हाउ. इसके बाद हम नए नए मटेरियल डेवलप करते हैं. इंडस्ट्री जो है, कंस्ट्रक्शन इंडस्ट्री, हर साल हर इसमें आपको दिखेगा कि नए नए मटेरियल्स आपको मिलेंगे. तो ये बहुत सारे एक सतत प्रयास होता है, रिसर्च होता है. दिस इज मटेरियल इंजीनियरिंग.
Okay, thank you, sir.
Hello, sir. This is Dr. Jayan Nirmakar from South Korea. Actually, I'm not belong to the civil subject. I'm belonging to atmospheric science, but I have some interest question on it. So, as we know, like in India, the construction is very important. Like we have a huge population. So, as I'm living in the South Korea, so here they have managed the things in a very small area.
Hello.
Okay.
Okay. Continue.
Yes, sir. So how we can implement this like management system that we have a big area, so we can use a small area for the construction and put all the things like all the utility of the houses of the like let's say bedroom, kitchen, and whatever the utility in a small area. It is not well popular in India. First thing. And second thing, sir, you're talking about the maintenance. Like we already constructed many things, but maintenance are always a problem for us. There's lots of good buildings, good infrastructure in India, but always they have a lack of maintenance. Because of that, we just lose that buildings. Like even though very very soon, because of the lack of the maintenance. So what should be our contribution? What should we do, and what can we contribute to remedial all these things in India?
Are you discussing with reference to India, or you're talking about Korea?
Preference to India. Preference to India.
India, for the India. Actually, I have visited many countries and I've discussed throughout the world exports. What I find that what I have told in this presentation is the reality of the world, not for the India, not from the India, but the problem of this rehabilitation and maintenance, if you say, it is, you can understand that the most developed country has already developed infrastructure, and they are hardly developing 10 to 15% new structures every year, isn't it?
Yes, sir.
So the maintenance, huge maintenance is required, and nobody is there to deal with. And our students are also not, we are not preparing them for this purpose. So we should prepare, we should bring such subjects into the basic BTech level, and also we should encourage people to go into this area as a professional.
So is it, sir, it needs to be modification in the education for the civil engineers so that they understand
yes, actually this,
of the subject?
Yes. I suggest that people should be given option of studying construction engineering technology and civil engineering. Those who wants to go in the designing part, they should go in civil engineering, and those who are interested in construction, they should go for construction technology, where I have told you this should be the proposal.
Yes, sir. Thank you so much for your answering.
Hello.
Hello. Yes, sir. Yes, sir. Thank you so much, sir, for your answering.
Thank you, जैन जी. कुछ पूरा ना हो पाया हो तो आप बात कर सकते हैं फोन में, कोई दिक्कत नहीं.
बिल्कुल सर. Yes, sir.
Sure.
Yeah. Okay. Thank you so much, sir.
Madam Bhumika, please tell me next.
Yes, sir. Thank you, sir. Thank you for this session.
Thank you. Nice to be with you, all people.
Thank you so much, sir.
Thank you. मैं बंद करूं?
हाँ, yes, sir.
Okay, thank you.
On behalf of the Organizing Committee, Third International Conference on Recent Trends in Renewable Energy and Sustainable Development, I take this privilege to Harsh Kumar Pandey as our session chair. Pandey is the head of the Department of Mechanical Engineering at Raman University. He is a PhD in development of polymer composite with glass microbeads. He has an experience of over 14 years in teaching. He is an established scholar and has guided so many students for his MTech projects. We are honored to have him as our session chair. I now invite Dr. Harsh Pandey on the virtual platform to introduce our guest, Dr. Manoj Kumar Gupta, Senior Scientist, AMPRI, Bhopal. Dr. Harsh Pandey, the stage is yours. Sir, Pandey sir, Harsh Pandey sir. We can see you, but please check your mic, sir. Good afternoon, Manoj Gupta, sir.
Good afternoon to everyone.
Sir, on behalf of IIT Raipur, sir, I would like to just apologize for the delay, sir. There was some technical hitch and a bit of confusion, so you need to wait for that, sir. We really apologize for that and really appreciate your spirit that you have been with us, sir.
Thank you. It's no issues.
Thank you very much. Yes, Pandit sir, are you ready with your mic, sir? Hello, Pandit sir, you are muted. Please unmute, sir. I can see. भेजे हो क्या?
मैंने कुछ भेजा था इसमें आपको मैंने पर्सनल अपने पर्सनल ये भी हमके गुप्ता करें
Dr. Manoj Kumar Gupta is at present a scientist and assistant professor, academic of scientific and innovative research. He is the recipient of CSIR Young Scientist Award 2020,
Sir,
physical sciences including instrumentation.
Hello.
His research area includes material sciences, thermal properties of materials and polymer composites, mechanical properties, nanotechnology, piezoelectric, dielectric analysis, and alternate energy. In his illustrious career, he has an upper hand in departments of physics and astrophysics and has also taught in University
दीपक
of
भाई मेरा
Delhi.
मोबाइल काम नहीं कर रहा है, म्यूट है, वो हट नहीं रहा है.
The current research interest that he possesses is in the field of synthesis of piezoelectric and ferroelectric nanostructures, weights to wealth, fabrication of advanced construction materials, hybrid composite materials, self-powered nanosensors and nanosystems. He has a vast experience as junior research fellow at Bristol Lab, Department of Physics and Astrophysics, University of Delhi, as a senior research fellow, as postdoc at at Sungyun University, South Korea. DST Inspire faculty, Indian Institute of Science Education and Research, Bhopal. The course and the discipline he possesses is in material science and engineering, research methodology, analytical characterization techniques, smart and functional materials. He is a vast traveler because of his scholastic knowledge. He has traveled to countries like South Korea, China, USA, San Francisco, and has been present in the Material Research Society meeting on 1st to 5th April. He had been to Finland. Now, just to give a brief idea about his honors and awards, as I mentioned, he is a Young Scientist Award winner. He is DST Inspire. He won the first prize as Best Oral Presentation Award at National Workshop on Renewable Energy and Environment, University, and he has won. He was runners-up in essay competition at Hindi Divas. His total research publication, total impact factor is 368, Google citation is 4054, and Scopes index is 27. With his illustrated career, it's time to hear his knowledge and learn a lot. I invite Dr. Gupta on stage to share his expertise. Sir, please.
Thank you, Dr. Shankar. I hope my slide is visible and I am also audible to everyone.
Yes, sir. Yes, sir. Please go ahead.
Thank you. Thank you for giving introductions. And first of all, I would like to thank conveners and all organizing committee of this conference who has given me chance to present some of the recent work on this area. So thank you everyone. Thank you Dr. Vikas Dubey and other members of this committee. So without any delay, let us start about renewable energy sources and what is new in this world actually. So today I am going to talk about smart, flexible, next generation piezoelectric nano generator. This is a new kind of the renewable energy sources. So in this talk I will highlight about some fundamental of the nanomaterials, nano composite, and then applications of the piezoelectric materials as a nano generator devices as well as smart nano power sensor. And also I will discuss about the various kind of the functional materials such as zinc oxide, graphene, zinc silicate, lead free and lead based materials for making these kind of the nano generators. And then I will also discuss about the two-dimensional materials and their role of increasing the performance of such kind of the tiny devices. And also I will touch the biocompatible piezoelectric nano generator for body implantable devices. Okay, so as we all know that these nanomaterials are very smart materials and they exhibit a very unique properties in all dimensional, whether it is optical, electronics or biomedical science. Everywhere the role of nanomaterial is fantastic, and any material which has a dimension less than 100 nanometer is termed as a nanomaterials. And when you mix these nanomaterial with some kind of the polymers, then the terminology comes as a nano composite materials. So there are two basic fundamental property which are associated with these nanomaterials. One, we know high surface to volume ratio. Once you decrease the size of the particle, the reactivity of the surfaces will increase several times. It means it can change the physical property, chemical properties, and many more. And once you talk about the electronic property, then if you see the 3-dimensional, 2-dimensional, 1-dimensional or 0-dimensional material, and once you plot a graph between density of state and the energy, you can see how they are varying actually. From 2D to 0D, it is steps like spikes line and line like structure. It means their electronic property can drastically change actually. Like band gap can increase, the thermal conductivity, electronic conductivity can improve, and we can control it. Now, coming on the basic things, means energy sources. We know today we are getting energy from the many sources, like it is coming from thermal power plant, so they are using the coal. Also, we are getting energy from the nuclear powers. We have oils, natural gases, but these are the conventional energy sources. Means once a day will come when we will not have the sufficient amount of the raw materials, so we have to move to the renewable energy sources. So currently what we have solar cell, where we are having the solar cell panels, and they are converting the sunlight into the electricity, and then we are storing those electricity in a battery, and then we are using to power the TVs and other electronic devices in our home. Similarly, we have biomass, wave energy, green energy, geothermal energy, but there is a problems with these kind of the renewable energy. Either they are very costly, either they are not portable, and either they are not available at every places. So we also need some kind of the smart and portable energy devices that we can carry actually in your pocket, and once you need the energy, you can power your electronic gadget through that devices. So how it can be possible? Now we know the power consumption spectrum. So it is in the range of the microwatt to milliwatt, and then it can go to the gigawatt. So the application of these power in the range of the portable devices like charging cell phone, lap tablets, sensors, watch, mobile phones. These area, how we can utilize the nano generator to power this smart and portable devices, that we will discuss. Now, like we know the fuel cell, thin film battery, sensor, pacemaker, they all need batteries. Lithium ion battery are conventional battery, but they have very limited lifeline. If you don't have battery, your watch will stop after some time, your mobile phone will getting to discharge. So you need to have some teeny devices that can power regularly without charging. How to do it? So we have piezoelectric phenomena, a very wonderful phenomena, when some materials, not all materials, some material shows this piezoelectric property. Means once you apply the mechanical pressure, an electric potential can be created across the surface of those crystals. It means you give the mechanical deformation, it will give you the positive and negative charge, and that is because of the non-centrosymmetric effect, crystallographic properties. So all crystalline material have 32 symmetry point group. Among those, only 21 shows the non-centrosymmetric property. It means their cations and anion can be displaced from the center of symmetry. Means dipole moment can be created in those crystals. So some examples we have quartz, SiO2, very famous example, zinc oxide, barium titanate. So till date, or even up to 5 or 10 years ago, we are using the piezoelectric effect in converse manner. Means like ultrasonic waves. If you give the electric signal, electric potential, the crystal will start to oscillate in frequency in the range of the micro, like we know the ultrasonic waves. So in that range we can create the frequency. So few years ago, one professor from the USA has developed the nano generator devices. Initially he has started, so what he did, he grew the zinc oxide nanowires vertically on conducting substrate, and then he did the piezoelectric force microscope of single nanowire, and once he hit the top area of the nanowires, then negative and positive potential was developed, and he successfully measured the current peaks. It means once the probe is touching to the top of the nanowires, then positive signal was created. It means if we can grow these nanostructures vertically and then apply the force, so we can get the electricity. This was the idea. Now we have battery, we have so why we need piezoelectricity? So we know the battery has a limited lifetime, means after 1 month, 2 months, you have to change the battery. But this is not in the case of the piezoelectricity. Once you have the kinetic energy, means motions, either you are walking, talking, moving, typing, anything where kinetic energy involved, there that energy can be utilized to power the devices. So it means no lifetime, unlimited time it can work. A very beautiful example I will show you. For some patient who has heart problem, they need pacemaker, and this pacemaker always needs some batteries actually, and after 5 years, 2 years, they have to go for surgery to change the battery, right? But if you have nano generator, then you can power those nano generator with the flow of your blood itself in our human body. So the motion of the blood can power the nano generator, and that can be utilized to power the pacemaker. So he don't need to go for the surgery. Now one more examples, like we have the roads where we are always walking, our car is moving. So we have a nano generator kind of the devices, piezoelectric materials. You connect them together in a series ways or parallel ways, and then once the motion of the car will go over the devices, then the energy will create, and that energy can be stored in the batteries or supercapacitor or capacitor that can be used to power the streets light and other applications also we can utilize. So this is how it can work actually. So the fundamental is when you breathe, when your blood is flowing, eyes blinking, any movement in the body, car running, vibrations from the air condition, these all can be converted into the electrical energy. Till date, these energy are just wasted in the environment. We are not using those energy. Now the flexible devices, this is the phone developed by the Samsung, right? You can see the screen is the particularly flexible, you can bend it actually, but the battery part is not flexible, it cannot bend actually. So very soon we will have the flexible batteries, flexible nano generator that you can roll up and you can put into your body or in your you can carry anywhere, you can fold it, you can put it in your pocket it's also. So to do that, what we did actually, I discussed that zinc oxide is a piezoelectric material, okay, and we need vertical aligned nanowires to create electrical energy. So we have grown the zinc oxide nano sheet, two-dimensional nano sheet, and that we have achieved through the vanadium doping in the zinc oxide. We try to improve the performance of the nano generator. So initially we developed this kind of the nano sheet on transparent substrate. We need flexibility also and transparency also, like what you see in some of the Hollywood movies. The screen is completely flexible, transparent. So the same way. So these nano sheets was developed on these flexible sheet, and this is the electronscopy images, SEM images. You can see the size of the sheet is approximately, height is 2 to 3 micrometer and thickness is just 10 to 15 nanometer. And once you see, this is the cross-sectional image, you can see these nanostructures are well connected to each other and they are vertically aligned, right? And this is the lattices image. It just shows that it is the zinc oxide, no other material is formed, the purity. Now you can see this is how we develop it. We have taken the substrate and then we form the seed layer, and then using the spin coating technique and vanadium dope, vanadium element, we successfully grow the vertical aligned nano sheet. Now whether vanadium is there inside the nano sheet or not, or where it is in the zinc oxide lattice on the surface or within the lattice, that we have confirmed through the X-ray photoelectron spectroscopy. Like vanadium can be in the state of the V4 plus also, V5 plus also. Just changing this electronic state will change the electronic property of the materials. So through the X-ray diffraction, we confirm that only C alignment is there in the zinc oxide. This is the ITU peak. And then this is the EDS spectra, just confirm that vanadium is there in the crystal. And vanadium we have utilized just because to increase the piezoelectric property. How? That I will show you. Now we have to find out whether piezoelectric property means D33, piezoelectric charge coefficient, this one. 3 means you are applying the pressure in the Z direction, and another 3 is you are getting the electric charge in the same direction. This is the picometer per volt. In 1 volt, how much deformation is there within the samples, that we are measuring with the voltage, and that is up to the atomic scale. We have grown the few zinc oxide nanoseed on platinum substrate, and then we utilize the piezoelectric force microscopy, and once we deform it, then we found that piezoelectric charge coefficient is high, 4. Usually it is 1 or 2. So 2-time enhancement was there. Now these nanoseed also shows the butterfly curves, means data storage capability. You can even store your data, digital data, as a memory device. So some hysteresis curve also we got. So this is the basic property, how we measure it. Now how to make the devices. So to make the devices, we need 2 electrodes. One is the bottom and another is the top electrode. So for the top electrode, we chosen the gold electrode because work function is very high as compared to electron affinity of zinc oxide. So what is happening, once you are applying a pressure, so you can see a peak is coming, and the magnitude of the peak is 1 microamperes. Means up to 1 microampere current you can produce once you are pressing it, and once you are releasing it, in 1 peak will also come in the negative direction, but it is not coming. This is just because the negative potential is there in the top side. Means DC kind of the output voltage was coming when you are pressing it and releasing it. Means you can use this output voltage directly, no need to convert AC to DC signal. Now when we make the same nano generator with the nano rod like morphology, means 1-dimensional morphology, then we got AC kind of the nature. First peak upside, second peak downside. Okay, but magnitude is lower, just nanoampere. That is not sufficient to power the mobile phones or LEDs actually. So here the current was very high. Now you can see this video how we are glowing the LED. Means once you are pressing the device, the LED is glowing. No other electricity, no conventional electricity, just by pressing it. Right. So this is how you can glow the LEDs. Now, as you know, once we are talking, we are creating the sound energy. Like this is the sound waves. So this sound wave is basically having the kinetic energy. So it means you can deform the nanowires because it is very flexible actually. This is a nano range now. So once you talk it, these sound waves can deform the nanowires, and then it can convert energy. It means you can charge your mobile phone just by talking actually. You just talk it louder and louder, you will get high electricity, and that electricity will charge your mobile phone at the same time. Means your mobile phone is not getting discharge in future. So this is the highlight of one of our published paper. Now there is a lot of deficiency is with the zinc oxide. We always need high output voltage. So how to do that? What is the material selection criteria? Okay, so zinc oxide is a very popular material. We can grow the vertical aligned zinc oxide nanowires through various techniques: CVD, PVD, sol gel, hydrothermal, spin coating route. But there is a problem. The problem is the high carrier density in the N-type zinc oxide nanowires. This is the semiconductor material. So in the semiconductor material, it particularly shows the N-type behavior. Means high electron carrier density are there. So once positive and negative charges are developed when you are pressing it, these charges can be dismissed because of the presence of large electron and also low D33. 4 is not sufficient. We need to go more and more D33. Then oxygen's vacancy, native vacancy, surface defects. So we have to choose some other material also. For that, we have selected the zinc silicate, and also sometime vertical alignment is not very easy task for all materials. All material has different crystal growth habit, different crystallographic properties, different vapor pressure. So we have chosen the zinc silicate nanostructure. This is very popular in the fluorescence applications, like for UV detector, fluorescent paint, UV LEDs. But for the first time, we have successfully grown the zinc oxide, zinc silicate nanostructures through the hydrothermal load. And you can see this is the TEM image, transmission electron microscopy. You can see these are not vertical aligned. These are randomly oriented, right? But the crystallographic lattice fringes is very clear, means this is the single crystalline materials. Now we have also measured the dielectric constant. So the nanoscale zinc silicate shows very high dielectric constant, up to 15,000, very high as compared to like bulk zinc silicate, because of the high number of the electric dipole polarizations per unit volume. So means high dielectric constant means it is good. Then polarizations will be also high. You can even store the charge with high capacity. Now we have also see the optical properties of the zinc silicate, and it shows that it is having the band gap about 4 to 5 electron volt. Few of the results we try to publish regularly in various journals. Okay, now again what we did, this was in the powder form basically originally. So we dispersed some of the powders in the conducting layer, and then we probe the atomic property at nanoscale. So you can see this is the topographical images and phase image of the single nanowires, and you can see it shows the very high displacement over the voltage with D33 of 117 picometer per volt. In zinc oxide it was just 4, but in case of zinc silicate it was 117 picometer per volt, very high. And it shows the non-centrosymmetric phase. Originally it was centrosymmetric. So we interestingly converted this structural property into the non-centrosymmetric phase. Now our goal was to make the device flexible and rollable. So for that we have chosen the graphene as a top electrode. You know, the graphene is a very popular material, and two of the scientists from the UK has also won the Nobel Prize on the graphene because it is flexible, transparent, it has metallic natures, very high surface area, high tensile strength. So many beautiful properties are associated with the graphene, but same time very tough to make it. And it has various applications in LED, wearable, touch sensor, in concrete reinforcement also for civil engineering purpose. So in our lab, what we did actually, we grew the graphene over the copper substrate to utilize them as a top electrode of the nanogenerator. So here you can see through the CVD technique, we first improved the crystalline property of the copper foil. Then by controlling the gases, we successfully grew the graphene over the copper substrate by the CVD technique. And then this is a Raman spectrometer. This peak always suggests that you have now achieved the monolayer graphene, means just one thick layer of carbon in two-dimensional lens. Now our challenge was how to transfer the graphene from the copper, because copper is the gray color, you can see. It is not transparent. You cannot see from this side to this side. So we have to remove the copper from the graphene. So we have one technique, wet transfer technique, So that we transfer this graphene from copper foil to the PET substrate, and this PET substrate we have used to make the top electrode on zinc silicate devices. So the zinc silicate was, you can see it is dispersed in the polymers. It was in the powder form. We need to make the device, so we make the nano composite with the PDMS, and then we use the graphene as a top electrode. This is the original image. This is the semi-transparent, and you can see this zinc silicate is randomly distributed, not vertically aligned, means just randomly distributed within the polymer matrix. And once you apply the pressure, now your nano generator is ready to perform. So once we are applying a pressure, just 0.5 kgf, 4 voltage is coming. And once you are increasing the pressure, the voltage is also increasing. So from millivolt to 6 to 7 volt we achieved just by tuning the piezoelectric properties and choosing a smart electrode like graphene. So this is how it works actually. You apply the pressure, the negative and positive charges will develop. Okay, an electron will start to flow from top to bottom electrode. It means current direction will be here, like from bottom to top. And once you release it, so all collected electron will again float back to the top electrode. And once reverse peak, you will get it. Apply, release, apply and release. You will get the output voltage up to 7 to 8 volt. And now this is the transparent, so we are applying pressure in that directions. Now you just put in your hand actually here and bend it. Once you bend it, it will also create energy up to 2 volt, right? So by human motion also, you can create the electricity with the very high output voltage and current. Now, whether the device will work for longer or it will just work for a few seconds. So we have tested the durability test. Means we measured the output voltage for hours, 2 hours, even for a day, and a very stable current density with the magnitude of 0.5 microampere we got it with the efficiency of 29%. Means 29% mechanical energy can be converted into the electrical energy, and that we just publish in Nano Energy. Now see how it works actually, how it looks. This is the device. When you are touching it, one peak is coming, right? Once you are touching again, the peak will again appear. Right, it means just suppose that this devices was fixed in just near to your eyebrows. Some person is sleeping, okay, so there will be some output voltage. Some person is driving the car in the highway, and you are putting the device over here. So once driver will sleep, so it means there is no vibration. So it will inform to the passenger that your driver is getting the sleep. So you can like aware that you can push to the driver, don't sleep. So it can work also like a smart sensor, not just for energy harvesting. Okay, so we have also integrated this device and we put the device into the road. Okay, and once we press it, like with your shoes, you can create electricity. See, wear it, integrate it with your shoes, and then walk, get energy, use them. So this is some of the publication in Journal of Applied Physics. Regularly we try to report our data, and this is a rollable device. Now in this condition, we have actually used graphene as a top electrode also, as a bottom electrode also, so it can be rollable. Okay, similarly, we have selected the zinc stannate nano cubes. This is in the cube-like morphology, means once you change the orientation of the cube, the symmetry will be same. It will look same. Either you are tilting in A direction or B direction or C direction. means symmetry will be higher than other morphology. So these zinc stenate nanocube we have achieved from the hydrothermal technique. And here, in that condition, we utilize the gold as a top electrode and ITU as a bottom electrode. And then PDMS was used as a polymer material, as a matrix. So here what we did, we put the device over the road and then we roll out the car on the device. I will show the real video of that one. Before that, we measured the output voltage. Let us see how much output voltage it can create once you are increasing the pressure. So up to the 12 volt we achieved under the pressure of 8 kgf, right? And if you change the concentration of zinc silicate in the polymer matrix, like 10%, 20%, 50%, we saw that it is higher in the case of 40%. Like once you increase the concentration and it passes the percolation limit, then all material will, like polarizations will be very high and conduction will started. So it is not favorable for high concentrations. So we do the simulation also, like we can utilize the console software and then we can simulate it. This work was also appeared as a cover page in Advanced Functional Materials. Now see this video. This is a device and this is the rolling of the car tires. You can see once the vehicle is rolling over the device, a peak is generating. Okay, means the idea was successful. In the same manner, like carbon nanotube, one-dimensional material, it has the metallic characteristics also and semiconductor property also. Both property can be obtained from the carbon nanotubes. So we in our lab, we are also using the carbon nanotube as a functional material, either as a reinforcement element with piezoelectric material or as a direct electrode materials. Like in some cases, we have developed the zinc oxide nano disc like structures, 2D structures. Okay, by the spin coating technique, you can see these nano discs are vertically aligned. How it was obtained, that we discussed with the crystallographic property of the zinc oxide. They have two polar surfaces, Zn plus, O minus, how the OH is binding over the polar surfaces, that we have discussed. And then here we have used the carbon nanotube as a top electrode. Like carbon nanotube has a zigzag structures, means once you apply over the zinc oxide, it can create high pressures, means the contact between carbon nanotube and nano disc will be high. If it is purely flat, then maybe it will touch few of the nanowire, but it is having zigzag structures, so it can create a lot of pressure. It means even under the small pressure, mechanical deformation will be high. And then at the same time, like there are many surface defects that is not favorable. So we remove those surface defects through the thermal annealing, simple, and we achieve output voltage up to 25 volt, very high. And this work was published recently in Nanoscale Advances. Now, the biocompatible devices. We know in our body, many patient has many diseases. Sometimes drug delivery is required, like pacemaker. In our body, a lot of kinetic energy is already there because of the blood flow. So the motion of that blood can also power the devices when it is utilized for some operation or for some surgery. So for that, you cannot use all material. You have to find out the biocompatible material that cannot harm your tissues, human tissues. For that, what we did, our student, they have collected the chicken egg, and then we have extracted the membrane out of the chicken egg cell. So this membrane is having the intrinsic piezoelectric property, and these intrinsic piezoelectric property can be used to make the flexible devices. So we peeled out this membrane from the egg cell, and then the morphological and structural characterization we did it. Then we use this membrane along with the PVDF polymer, and we make the heterostructures of PVDF and egg cell membrane, and then silver paint was used. And like FTIR, we just found out that our beta phase, like piezoelectricity in the PVDF, was high. Now, once we measure the output voltage and output current under mechanical force simulator at different frequency, we found out that we can achieve up to 15 volt or 10 volt based on the how pressure you are applying. Even under a small pressure, a lot of signal is coming. So it means these can be also utilized as a nano generator material, and this is the nano generator what result I was showing. So how it work actually, what happened inside the egg cell membrane? So there are a lot of peptide bonds are there, a lot of proteins are there, and once we are making the interface of PVDF with the egg cell membrane, so there is a synergy effect with the, and a lot of other organic covalent bond is formed with the PVDF materials. And then to confirm those bonding, we measure the dielectric constant, and we got very high dielectric value. It means key polarization is high. And this work was also recently published in Journal of Alloys and Compound. Okay, so now this is for the mechanical energy. When you are moving, talking, just typing on the keypad, right? But in nature, we have the thermal energy also, like from AC. You can see the thermal gradient, sometimes heating, cooling, heating, cooling. So the temperature difference and the fast difference. The fast difference basically gives the thermal gradient, right? And those thermal gradient can be also used to convert into the electrical energy by pyroelectric effect. Means some material which has a piezoelectric property. So not all piezoelectric material, few materials also shows the pyroelectric property. Means if you apply the heating or cooling, the electric dipole will change, and the change in the electric dipole will give you the electrical energy. So we have created the stretchable devices. In the stretchable devices, that devices can be wear in our human part actually, in anywhere. So to make these stretchable and wearable devices, it can be stretched out. Means you just peel it or put it any places in your body, it will not damage actually. So to make these devices, we utilize the carbon nanotube as a bottom electrode, graphene as a top electrode, and PVDF as a center. And then by the lithography technique, we made the pattern. Means a pyramid-like structure we make over the devices. And then we measure the output performance under release condition, release or compress, and at the same time, we apply the heating also. So we integrated thermal gradient also and mechanical energy also. And we found that the output voltage is increasing. Means at the same time, you can harvest both the energy, thermal as well as mechanical. This is some of the images, like it can also work as a pressure sensor. And this is the last work I am showing it. Recently, we have also developed the hydrophobic, ultra-sensitive PVDF carbon nanotube foam nanogenerator. What happened if
Manoj
there is
Gupta,
a... Yes.
Sorry to interrupt, sir. We are running out of time. If you can please conclude.
Okay.
Okay, sir.
Thank you. I am concluding it. Thank you.
Yes, sir. Yes.
So
Yes,
this,
sir.
yeah, just I will take few seconds only.
Yes, sir.
So this work, we have developed the foam, hydrophobic foam. Means in the raining condition also, or when the device was dipped in the water, you still get the output voltage. This is the SEM images. You can see the how pores are created there. And at a various relative humidity, you can see the output voltage is slightly decreased only. This work was also published in recently. Okay, since the time is limited, I am going to come on the last slide. And this is the harvesting solar energy along with the mechanical energy. Few of the work is also highlighted in the Discovery News, National Geographic channels as a variable motions. Thank you all.
Thank you very much, sir, for that fruitful session. Indeed.
Thank you, sir, for your. Myself, Harsh Pandey. Due to my audio jack problem, that's why sorry for the
No
inconvenience.
issues.
Sorry. Do you have any question from the audience, from the participants? Do you have any question? Thank you, sir. Thank you for your wonderful presentations. Thanks a lot.
Thank you, Dr.
Good day.
Thank you.
Thank you very much, sir.
Thank you,
Manoj,
Dubey sir. Thank you, Manoj sir. I take this privilege to invite Dr. KVR Murthy on the platform as our next speaker. Dr. Murthy is a PhD from MS University of Baroda, is a fellow Luminescence Society of India awarded on 15 of Feb 2008. He is a fellow AP Academy of Sciences. He is a professor CSAD since October 2002. He holds as Secretary Luminescence Society of India from till 2012. He also held the post of a Chairman Luminous Society of India Gujarat chapter from 2004 to 2006. And then he has got from France. He was awarded from Boiron Labs with visiting researcher as a visiting researcher to work at Aerial CRT Research Center on low temperature thermoluminescence electric France. He has examined over 135 PhDs. His topics of interest are photoluminescence of phosphors for lamp and display applications, nano phosphorus for display application, thermoluminescence and application published applications. Sir has published more than 600 papers in various journals and conference proceedings. He is a member of international scientific bodies. One of the papers was read in Luminescence Phenomena in 2014. Sir is also a rigorous traveler and he has been invited because of his vast knowledge on this particular field. Sir has visited UK, Denmark, Italy, USA, China, France, Netherlands, Germany, and his two major research projects amount to over 50 lakhs are sanctioned by BRNS AICT working with this, and he has been working with display industries for their R&D work. With such an illustrious career, we are honored to host Sir in Flesh and Blood 2 years back. And on behalf of the BIT family, I take this privilege to once again invite Dr. KVR Murthy on the platform. Sir, we are honored to have you and we are eager to listen to you. Thank you very much, sir. You may please start.
Thank you for your kind words.
Thank you, sir. Yes, sir. Please continue.
The entire screen. Yeah, can you see? Hello?
Yes, sir. Your screen
the...
is not visible, sir. You may please start sharing the screen.
Yes, I already shared.
Oh. We are not able to see your screen, sir.
This is asking cancel.
Sir, screen is not visible.
Yeah. Just you can see now.
Okay. Okay, sir. It's
Now
it is
it's
visible.
okay, sir. You may please start, sir.
Yeah, it's okay.
Yes, sir.
Yeah, good afternoon, everybody.
Good afternoon.
Yeah. We are delayed by a bit. So now I will present my talk. Phosphor for energy harvesting. Everybody knows that without sunlight, we cannot assume the life on the earth. So you go back to millions back. So that is a fireball. From there, slowly it cooled down, and elements, rocks are formed. And because of sun, we are getting energy to our Mother Earth from billions of years. Light is at the origin of all life. It plays a central role of human activities and has revolutionized the society through medicine and communication, entertainment and culture. So if you go back to, say, 5,000 years back, not much. So the light is preserved only through oil lamps, lanterns, or continuous burning of the wood. From there, so we have light flash-based light system, solar-based light system, and dynamos, motors, everything developed because of energy. Which energy? Electrical energy. So the solar energy is the base. From there, all others are coming. Light is also important to our appreciation of art, and optical technologies are essential in understanding and preserving cultural heritage. The light becomes a key cross-cutting discipline of science in the 21st century. It is essential that its importance is fully appreciated. It is equally vital that the brightest young minds from all areas of the world continue to be attracted to careers in this field. So whatever you want to do, basic is the light energy is required. So light is required. For light, you require electrical energy. So much material science has been developed, including earlier talk about piezoelectrics and giving the LED flashing. So that is also one type of technology which is yet to be established. But presently, the established technologies, so wind energy and hydel energy, solar energy, thermal energy, nuclear energy, tidal energy, so many are there. So here, to combine the solar cells, I propose, and some experiments we did, up conversion. Everybody knows the down conversion. In the luminescence, there are two phenomena. One is up conversion, another is down conversion. Down conversion is absorbing the high energy, giving in the visible region low energy. But in up conversion, absorbing IR radiation and giving emission in blue light. So blue light is mostly absorbed by the solar cell. See, this is basic fundamental things. There are many mechanisms which can excite an electron to a higher energy level within a trivalent ionized radius, resulting in up conversion luminescence. This is a standard definition. The simplest and most logical up conversion mechanism involves a ground state absorption, that is GSA, process followed by an excited state absorption, ESA. These both processes are standard. The upper state lifetime in a solid state, gain, medium, are more generally the lifetime of a metastable electronic state of a dopant ion in such a medium can be strongly reduced by decay process, which involve the simultaneous emission of several phonons. Such process is called multi-phonon transition. This because of this multi-phonon transitions at a time, the time is around 10 to the power minus 8 to 10 to the power minus 6 seconds. It is not a fluorescence, this is a gain. So, some are the multi-phonon typically required for such a transition because the energy of a single phonon is not sufficient to match the difference in level energy. So these are the green, blue, red visible regions from terbium and from europium, ytterbium. So the ytterbium excitation is 975. So we are excited with the 975 IR radiation, we will get a green and yellow region, ytterbium emission. The rate of multi-phonon transition decreases exponentially with increasing number of phonons required. So this is important point one should understand in upconversion processes. As a consequence, a certain metastable state may exhibit a very strong reduction in its lifetime by multi-phonon emission if the host medium supports phonons with relatively high energy. Relatively high energy means coming to the red. See, we are talking about IR around 980 nanometers, say. So relatively red is 625 or 600 to 700 nanometers and giving emission in yellow blue. So there are many upconversion phosphors work only with the gain media, which may have small phonon energies such as heavy metal ceramics, so that sufficient lifetimes of certain energy levels are achieved. See, this is more important. Sufficient lifetime. Lifetime normally in fluorescence or photoluminescence, we talk about 10 to the power minus 8 seconds or less. So here still less energy, so still more time is required. That is around, as I said, 10 to the power minus 6 to minus 8 seconds. That is called sufficient lifetime. So you see that wavelength and can be calculated using following wavelength. So we basically I discussed up to 650 nanometers. So 254 nanometer is basically mercury resonance line. So the energy is 4.88 electron volts. So from there you can come to 460, 467. That is blue LED lambda. This is that is around 2.66 to 2.69 electron. So whatever blue LED, which is invented by Nakamura and company in 1996 in Japan. So that led to revolutionize the light emissive devices and the display devices like your mobile phone, like your LED TVs. So these are some of the energies for general understanding I am presenting, so that you can see that suppose 650 nanometers we are getting a blue region 467 or 460 nanometers. So how 1.92 is giving to arise 2.65 electron volts. So this is high gain media. No, many phonons are absorbed there. So basically, this is international event is energy systems. So we have a standard prediction. Global energy demand, yes, is not growing properly. So it's steady growth. But India and China, the demand is very high. Demand is very high. See, up to 2020, this is the demand. That is, so capita per kilowatt. So China, that includes human needs as well as industrial. So renewable energy sources, as I already told, so solar energy, so that is very high, terawatt, at 2.3 terawatt. Wind energy, 14 terawatt. Tidal and ocean energy is hardly 0.7 terawatt. Geothermal, 1.9 terawatt. Hydroelectric, 1.2 terawatt. Today is only 0.6 terawatt are installed. Biomass, 5 to 7 terawatt, all including. So this is a source from US energy sources. Let us see about the little background of light. So any light visible, we talk about only visible, not IR. So between 360 nanometers to around 700 nanometers, where our eye can detect, this is the visible region. So others, you have gamma, gamma to X-rays to ultraviolet, infrared, radio waves, etc. So anyway, other applications we are least bothered, everywhere we are using. So any energy between the infrared to gamma ray and leads to give white light in the visible region, that is luminescence. So absorption by our light by atoms to see that E0, E1, what is the difference, how it is absorbed, occurs only when the energy of the light equals the energy of transition of an electron. So single electron transition in a isolated atom. So in luminescence, nanoparticles nowadays people are discussing, and why it is discussing is, at a time from a crystal, only one photon will come out. So number of particles increases, the number of photons increases. So that is the reason nanometal research in luminescence is in progressing. So here again, absorption of light by molecules. So these are the possible electronic branches that are shown here. So molecules have multiple atoms bonded together, more energy states in the molecules than atoms, more electron jumps possible, light with a range of frequencies are absorbed. So this is what it is. So many excited more states are available. In the atom, only one state is there. So because the molecules, that is crystals, so we have so many jumps are possible from one state to other state. That leads, if a good molecule in a luminescence is there, white light is possible. With the blue excitation, white light is possible. So solar radiance receiving Earth, that is 1.37 kilowatt per square meter. Okay, so this is per hour. It is supposed to be 1.37 kilowatt per hour per square meter. So if you see that, so near UV, this is UV to yellow, violet, blue, green, yellow, orange, red, and near IR. So this is what it is. So solar cell working principle, if you see, simple. So you have thin film solar cells produced from cheaper polycrystalline materials and glass, that is silica solar cells. High optical absorption coefficient are required. Band gap suited to absorb solar spectrum. If you see that, that is the reason I showed the table. What is the energy of different lambda. So basic what is solar cell is a structure that converts solar energy directly to DC electric energy. It supplies a voltage and a current to a reverse load, that is light battery motor. Power is equal to current is general equation. Basically, it is like a battery because it supplies DC power. So long back, maybe 98, 99, we suggested to the government of India. So give a simple solar panel, and in those days, LED light just coming, white LED, that is, so for tribal hamlets, so it's a small battery, so inverter is required, directly charges and gives the solar output of 3.5 volts with some current. So a simple 2 to 3 watt LEDs will flow. So this is the first generation gallium indium phosphide. They are very expensive. Efficiency is projected real worldwide efficiency at 500 tons. This is third generation solar cell. So efficiency, they talk about third generation, but as on today also, we have less than 10% efficiencies are possible. That is the reason, if you put so big solar panels, I have a 3 kilowatt solar panel, which is approximately 15 square meters. So 15 square meters into 1.3, so at least 2 kilowatts per hour we should get. But 3 kilowatts what we get is only for 10 hours. So because efficiency is 10%. The physics here, the absorbed phosphor particles absorb a photon forming an excited state. The excited state of the phosphor can be thought as an electron hole pair. Then EHP is there, we have the excited state transfers an electron to the semiconductor TiO2, the electron injection. This separates the electron hole pair, leaving the hole in the material. So this is a current. 2 cells is parallelly we can have, so normally resistance is very large. One solar cell is 0.3 to 0.4 volts. So that is the reason if you see the solar cells, so many cells together, they keep the final output, they take only 3.5 volts. Here, this is the standard windmills. They are there since 100 years. If you remember, all the windmills are there in, especially Netherlands. If you go and see Netherlands and Denmark, so much wind energy they use. Since the Scandinavian country, lot of breeze is there all the time. But in India, so we study so much, so wind direction, everything, we install the windmill, which is costing around 2 crore rupees and connected to the grid. Sometimes that turbine is not at all rotating. So nowadays, hybrid technology, people are adapting. A solar panel, they put whatever the output of this big solar panel, maybe 10 kilowatt solar panel, efficiently we get 2 kilowatts. So the 2 kilowatt solar DC power is directly giving to a motor, which is attached to the windmill. So even though wind is not there, so because of this motor movement with a gear mechanism, the constant speed that at least daytime 10 hours, that the windmill works and we get a AC current, and AC is directly given to the grid. So that is the latestly people are working on much. So hybrid windmills are working. Wind is driven by solar heating. Largest and fastest growing solar energy conversion system. So here, the first statement, wind is driven by solar heating. Not even wind. So the tidal waves, especially maybe in big lake and or in sea, where are the big tides are there, it is nothing but a wind is traveling at a higher speed on the surface of touching the surface of the water. But the wind is driven by solar heating. That is important. So finally, what is your basic thing, what you are getting, whatever you are saying for rain or for anything, so your solar energy is required. So energy receiving from the solar sun is abundant. See, this is a global renewable energy sources. Okay. So Earth's energy budget, if you see, so incoming radiation, if you say it is 100%, if you assume, so what is happening in the atmosphere? The atmosphere is not 100 kilometers, it is just hardly below the ozone layer, around 30 kilometers. Reflected by atmosphere 6%, reflected by clouds 20%, reflected by another clouds, low level clouds 4%. And you see others, absorbed by clouds 3%, and which is receiving at the sea level or mountain level or ground level. Finally, 61% is reflected, Okay. So total majority is reflected. Even though what we get on the surface of the earth per square feet is 1.37 kilowatt per hour. When it is possible, there are no clouds, low level clouds or high level clouds, then only it is possible. If when the clouds are there, and automatically you are receiving solar energy, radiant energy is decreasing. So radiation properties of the atmosphere. Okay. So different properties absorbed by water molecules and others. You can see the total atmosphere is 100%. So outgoing is given here from different levels outgoing. So there is a methane. The atmosphere, that is the reason where our global ecologists say that methane heating is more, methane heating is more. So there, see that 0 to 100%, methane absorption is more. Okay. So different levels, carbon dioxide, water molecules, and then O2 and O3, ozone layer. So ozone layer is absorbing other radiations not visible. So here, some of the materials what we prepared, emission excitations we see. So this is the wavelength versus scale emission intensity. Very high intensity are there. Another material, 395, 467, emissions, excitation. The present phosphor, basically, barium yttrium oxide europium is synthesized by using basic solid state reaction. The emission is around 620, 612 is basic europium 3+, excited with different excitation, like the emission in violet to yellow region. All the emissions are allowed transition of europium 3+. And the phosphor is excited 649, 760 and 787. The emissions are found to 589, 595, 613. This one. So this is the emissions when you excite with IR. 640 is 650 is red, 760 onwards IR. Okay. So what the emissions are around yellow to red. So which is an upconversion luminescence. This phosphor can be a future candidate for near UV blue LED material. This material is also good upconversion material where we can use. So another material, barium strontium ceriate europium. So this is excitation lambda. So 595 is almost orange red. So upper state lifetime in a solid state gain medium, or more generally the lifetime of a metastable electronic state of a dopant ion in such a medium can be strongly reduced by decay process, which involve the simultaneous emission of several phonons. Such a process is called multi-phonon transition. So this is the basic condition for upconversion material. Multi-phonons are typically required for such a transitions because the energy of a single phonon is not sufficient to match the difference in level energies. It is known fact that general green, blue, or red visible up to upconversion luminescence from TB3+, and so on. So transition, UV3+ transition respectively. These are allowed transitions of upconversion also. So a solar cell, what it is if you see that N and P is basic solar cell. So and the light is received different colors. You see that red, violet to red, which is absorbed. So where is the upconversion phosphor is there is this one. All black dots are there. The coating, since this is a semiconducting material, the light is directly transmitted to that. And the phosphor material absorbs and then back of this there is a reflective coating. So whatever the light is coming, emission from this upconversion from this material particles, and go back to the again p-type, and efficiency can be improved maybe for 3 to 5%. That's what it was a suggestion from our group. The investigation on the spectroscopy and excited state dynamics of these systems is extremely important in order to understand the upconversion processes observed in the present phosphor system. Some challenges we discussed. Basically understanding the electronic and optical properties, especially band structure and charge transport, are they really condensed solid state amorphous semiconductors. So these some of the suggestions we made. Thank you very much.
Thank you very much, sir, for a very relevant and very understandable presentation. I request anybody has a question for sir. Thank you very much, sir. On behalf of BIT Raipur and organizing committee, I express my sincere thanks for your valuable time and expertise.
Yes, Neha, you understood something? Neha is a women scientist at Government Science College, Durg.
Neha ma'am, sir is asking something.
You understood what I said, since you have to do some research in this area also.
Yes, once a guide, as always a guide, so they would keep on asking us to push our limits and
No limit. Guide will not put any limit. He will load the student. That's all. Learn. That. See, this teaching field, teaching and learning is a continuous process till your death.
Yes, sir.
Not
And
till
we are
your retirement.
honored to have your guidance and motivation, sir.
Okay, thank you.
Thank you very much, sir.
Okay, you're
Hello,
breaking for
sir.
lunch? Yeah.
Hello,
Tell me.
good afternoon, sir.
Yeah, good afternoon. Tell me. Tell me,
Just
Neha.
I want to say good afternoon, sir. It is
Thank
nice
you.
to see you.
Yeah, lunch time. Go to lunch.
Okay, sir.
You're breaking lunch for lunch or?
No, sir, we are continuing.
We are continuing.
You're continuing. Okay.
Yes, sir.
Okay. Thank you. Thank you very
Okay,
much.
sir. Okay, okay.
Now,
Thank
I
you, sir.
have a privilege to invite Dr. Neha Dubey on the platform as a session chair. Madam, on behalf of BIT Raipur, I, Ravi Shankar Panikar, take this privilege to welcome you.
Ma'am, please on your mic.
Thank you so much, sir. Thank you so much, sir.
Yes.
Am I audible?
Yes, ma'am, you are audible. The
Okay.
stage is yours, ma'am. You may please start with your session.
Okay.
Okay, thank you.
Okay. So for the next invited talk, I want to invite Dr. Santosh Sar, who obtained his PhD from the Pandit Ravi Shankar University, Raipur. He has carried out the postdoctoral research fellow at Department of Chemical and Dynamic Engineering, South Korea. He has been awarded a research fellowship by the Council of Science and Technology, Bhopal. Presently, he is Professor of Applied Chemistry, BIT, Durg, Bhilai Institute of Technology, Durg. His more than 100 research papers have been published in various international and national journals, 2 books in Lab-Lambert publications. In his name, few patents registered at Indian Patent Office. Presently, he is the Chairman, BOS, Applied Chemistry and Dean of BIT, Durg. Today's topic of talk is status of uranium in Indian scenario and its removal technology. So I would like to invite Dr. Santosh Sar. Please deliver your talk.
Namaskar, madam. Thank you. Thank you, Dr.
Namaste, sir.
Vikas Dubey, sir. Namaskar.
Thank you, sir. Namaskar, sir.
First of all, I am thankful that is our own institution.
Yes, sir.
Though they are continuously working for this international conference. For this international conference, I congratulate your team. Directors are Dr. T. Ramarao sir, Principal Dr. Anup Mishra sir, and the convener Dr. Vikas Dubey sir. So I am congratulate on behalf of BIT Durg and Applied Chemistry Department, and as Dean in CSBTU Bhilai also. So this is a very good effort.
Sir, thank you.
In my purview, I wish to talk about half an hour for uranium, status of uranium in groundwater of Chhattisgarh as well as Indian scenario and the removal of this system. So just I share my lecture. Yeah.
Yes, sir. It is visible now.
Visible.
Yes, sir. Visible.
Okay. So that is a story of uranium in Chhattisgarh state. First of all, this work is collaborated with initially Department of Atomic Energy and Bhabha Atomic Research Center. That project was given to Bhilai Institute of Technology Durg as well as Raipur for 6 districts as well. So this work is started with Department of Atomic Energy for the determination of uranium in 6 district around our Durg city. So earlier this work is going towards PhD for 3 of my students for the determination as well as the removal technology. At the end point, they develop some removal technology with chemical as well as bioadsorbent. So later I make a MOU with Turkey and Bosnia, Europe for development of removal technology. So this poster, which is shown the Age University, name of the Age University Turkey, where we take an MOU for the collaborative work for this removal technology of uranium. That work is presented in 3rd International Conference on ICRT RSED. That is the theme of this conference in Bhilai Institute of Technology, Raipur. So I could not read this lecture, just I inform you what are the going on with this system or with this system. What are the things which achieve Government of India from the 67 scientists who are working around our whole country. So first of all, this uranium contamination will be determined, make a blueprint for the 728 district at I think that is in 2018. So this 728 district was given towards 67 scientists, means like professor or scientific officer like this. So these 67 persons given the data of uranium in DAE. So what are the purpose of this data? Main purpose of this 14 parameter data that is to make a blueprint of uranium contamination in groundwater, or how we find in our country where uranium can be possible to for mining, as first uranium contamination of our country is here in Ranjangaon district. So the theme to work with this uranium contamination of DAE, that is Public Health Department, to find out the uranium contamination or make a blueprint for uranium all over the country where the possibility of uranium can be happen. So these data are useful for our country initially from 2016 to 18. So we have submitted all the project from all over country, from Kashmir to Kanyakumari. So that is, I think, 2019. That the software of uranium contamination for all over the country is also fabricated here at Bhilai Institute of Technology, Durg. So we see all the data for the Department of Atomic Energy. So that is confidential. So we could not say that how many points where uranium can be available or may be available for uranium mining in our district, Durg. Around my work, I can say, because that all the things are published. So from this first slide, occurrence and source of uranium in groundwater. So main uranium contamination in earth crust, that is the label, and some information from how uranium can be possible in groundwater. So natural source are there, anthropogenic source are there. So the natural source can be your geological source or the rock formation or geology, and anthropogenic source, that is the power plant or fossil fuel or fertilizer. So health effect of uranium. Now there is a limit for anything. If you go for water testing or if you go for any ISO standard for any material or any testing consultancy, so there will be a limit for up to that fluoride concentration must is okay, no problem. Up to that arsenic contamination is no problem. So as per our government, as per Atomic Energy Regulatory Board AERB, the limit of uranium is 60 microgram per liter. And as per World Health Organization, that is 30 microgram. And as per US Environmental Protection Agency, that is also 30 microgram. But in our country, we have decided that is 60 microgram per liter. So now our work or all over the country, we are working for our DAE that where the point the uranium contamination is more than 60 ppb per liter. So for that there is a meter provided by our DAE, that is LF fluorimeter, LED fluorimeter. So first thing that why this work will be happen in our country to find out a blueprint of uranium contamination in our rocks or in our geology. So after that, what are the health effect of uranium? Actually, the uranium is mainly disturbed or mainly deposits in bones, livers and kidney. So if it is in more than this label microgram per liter, then this water can be affect the bone, liver and kidney of that area. So that is another part, main part, that if there is uranium, then how the country will be benefited with this uranium contamination, or how we can save our life from this uranium contamination. Both parts are there. So first of all, this is the world scenario where uranium contamination, if you can see this slide, then you can see in our country, Himachal Pradesh, Karnataka, North Rajasthan, Karnataka, then Punjab, Bhatinda, West Haryana, Eastern Uttar Pradesh, Kerala and Jharkhand. There were ultimate half portion of the world scenario. You can see the uranium presence in different ranges, that is from literature source. So from 2010 onwards, we are working for this uranium. Turkey is here because we are collaborated with Turkey. So we write what is the concentration of uranium in Turkey in groundwater. So concentration level in microgram per liter, ppb level.
वहाँ चल रहा है कि नहीं भाई?
Hello.
Yes, sir. Continue. Please continue. You are visible and audible. Visible and audible.
So that is world scenario. My lecture is nothing that I am giving a scenario of uranium contamination and its presence and its utility as well as health effect towards our country, towards our state, towards our district. So I started this with we are collaborated with DAE initially for determination of uranium. We think we have got so many instruments from DAE, and with the help of this, we have produced 3 PhD students here and 15 SCI and Scopus paper. At last, we have also produced a patent also with to remove this uranium concentration, contamination. So what are the theme up to world level, world scenario? In this slide, you can see. Next slide, work carried out in this field. So many work are carried out with this field, but in my case, I have done with Durg, Bemetara, Balod, Rajnandgaon, Kabirdham and Kaket district. Here, I must say that Rajnandgaon is a district where we have got first uranium contamination in Budal mines. That was in 1960s to 70s. With the help of this uranium, our country made the atom bomb in our defense organization that is from Rajnandgaon district. Budal mines is also there, and here now also we have find the water level or water is contaminated with still uranium contamination, and that is reported to DAE as well as in research paper also. So treatment technique for resolving uranium contamination, as you know that every scientific community should not aware that how you can find out the toxic elements or toxic things. We must give the treatment technique also to remove this these toxic elements. Here our toxic element is uranium contamination. So initially, coagulation, sorption, solvent extraction, membrane separate, membrane technology, ion exchange, biological method, and major treatments are this type of major treatments are applied to resolving uranium contamination. Most of these approaches have been disadvantages, especially treating large amount of dilute effluents. Absorption is the better technique. So first, when we develop anything, we are going with batch absorption technique in laboratory. After that, we are going for column absorption technique. So initially, we are developing the method with batch absorption technique, and now we are going for column absorption technique, but still we are not produce any research paper for column absorption technique. Earlier, our PhD student, means my PhD students, working for batch absorption. So papers are there in batch absorption. Even the patent is also with batch absorption technique. So first we are see what is the world scenario, how uranium is here in Rajnandgaon district since 1960. So in our study, we are determining the 6 district of Durg and around 5 district, and some technique developed to remove this or resolving this uranium contamination. So how this location can be classified? You can see this is our country. In this country, you can see this is our state, Chhattisgarh state, and yellow portion is showing your Balod location. And you can see the Balod location is having some sampling points. So sampling points, as you know, or in our literature told that Balod is 3,526 square kilometer area, and in between longitude or latitude. So we cannot go every portion of Balod. We are as per the protocol of DAE, we are making 6 square kilometer grid mapping of any district and find out the approach area to get the sampling points. So you can see the Balod, this part is Tandula river or the Naxalite problem part or hill part. So there is no water source, or there is no tube well or sump well or anything. So we are, you can see this sampling area is that location only by 6 grid square kilometer area. Next is our own district, Durg district, that is 22,238. Same protocol is here, India, Chhattisgarh and Durg district. And you see that Durg district is almost covered because everywhere that is in plain. So everywhere we can approach the sampling process. Then next is Bebetra district. Bebetra district is also approachable. Then next is Kanker district. Kanker district, you can see some area is not approachable due to hill or Naxalite problem. So you can see in this slide that granite or basalts or which type of formation of geology is there. Next is Kabirdham district. Then these are the sampling points where we have taken samples. That is your well. This boy is now in Indian Institute of Science. Earlier he is employee of IIT Bhilai. Then now he is employee of IISc Bangalore, and he has done PhD from CSBTU Bhilai. These are the sampling points. So these are the sampling point, and our staff is there and research scholar is there. That is the sump well where whole community use this water. This is again sampling point. So well, and so earlier I also told what is the philosophy of this research work or title. That research title or this research work is generated by our country main agency, that is DAE. So I think this is not to be discussed. Novelty or outcome of this research. So that outcome of this research is the Atomic Mineral Directorate need what are the points where they can approach for uranium, and what are the points where a blueprint of uranium can be possible. So earlier Sukma, Dantewala, these areas are the main point of AMD. Now after this work in our country, they approach so many points for determine so find out the uranium or any radioactive element. This is the meter. This meter is here just beside me. You can see that if camera is yeah. This meter is here. This is LED fluorimeter. So LED fluorimeter is here. So with the help of that LED fluorimeter is provided by BARC project, and these are the parameter: pH, conductivity, TDS, ORP, hardness, alkalinity, chloride, fluoride, and sulfate, nitrate, sodium, potassium, uranium. Determination of uranium is by LED fluorimeter, or by determination of another points by this method. The methodology flow chart is here. Sampling of pre and post monsoon sample, grid mapping of sample first, then pre and post monsoon sample. So before sampling, we have to take GPS standard of the sampling point and gamma dose radiation of sampling point, and it should not be more than 100 millisievert. We have to taken care before pre and post monsoon. So these are the parameters by which we can determine the correlation of uranium present in groundwater. This is the table by which we can see how uranium contamination for the pre and post monsoon. These are the tables for Kabirdham and all 6 districts. Surface value of the table in this analysis of uranium. You can see this is the pre-monsoonal phase, and you can see that is the post-monsoonal phase. Distribution of uranium, you are easily seen in this map, how the uranium can be distributed. So in that is the graph for Balod district. Next is the pre and post monsoonal for Kabirdham district. Next, that is your Ranjangaon district. And these are the district we have measured the uranium contamination and other parameters for water quality. Kabirdham, Bemetra, Durg, Ranjangaon, Balod, Kaker. Same all over country, 728 districts are covered by another 66 persons. So this is overall map of uranium concentration in water sample from Chhattisgarh region in the summer and winter season. This is health risk. As you know, if any person is taking poison or toxic metal or toxic rays, then the limit of his or her age may be some years. So that can be calculated with our excessive lifetime cancer risk dose. That there is a statistical formula by which we can see if with dose and uranium concentration what is the cancer risk for due to this metal as well as the gamma dose radiation. Correlation studies, mainly uranium is correlated with TDS and phosphates and other metals that is shown in table. Remediation technique for uranium in aqueous phase, as I told, that anything is not determined by toxic element, it should be removed also or resolve also with some technique. That is the moral duty of scientific community. So we also tried for that. That is the treatment technique uranium concentration by first dolomite method. That is not very good for removal technology. That is up to 75 or 80% only, because dolomite is our own mineral, which is very much limestone, and dolomite is very much here at our state. All over Chhattisgarh state, we can find limestone or dolomite. So we have tried with dolomite, and it's also published in journal. So that is the data of dolomite with Langmuir and Friendlich curve, which curve is fit for best curve is fit for, that is 9.85 correlation coefficient. That is the same image for dolomite before and after adsorptive extraction. That you can see that EDS image, you can see here uranium is not after absorption. In B part, uranium is there. Effect of various parameter to set this removal technology, we have to maintain what should be the pH, what should be the contact time for best technology, what will be the.
Excuse me, sir. Hello.
Hello.
Please conclude, sir. Conclude your result.
Hello. Hello.
Hello, sir.
Conclude. थोड़ा
जल्दी करना है. जल्दी करना है क्या?
You have 5 minutes, sir.
Yes.
Okay.
You have 5 minutes.
Okay. So these are the removal technology. So at last, these are the another technology by we are going for removal of the uranium. And next. These are the another part by the radiation effect of uranium area, that gamma dose is also affect the population of that area. At last, the gamma dose is indoor and outdoor system. These are the gamma dose effect of uranium, and then the lifetime risk cancer risk will be also here. Then we are thankful for financial support of BRNS or DAE and TechU project of CSBTU for this. Under my supervision, they are doing their PhD and awarded PhD. There are 15 students under my supervision. They are obtaining his or her PhD degree here in our laboratory of Landstock Technology, Durg. Under this project, these are the publication. These are also published in WHO Outdoor and Indoor Gamadose Rate during COVID-19 period, WHO site and in journal also. This is the patent which is published in Indian Patent Office with the removal technology of uranium. Thank you.
Thank you so much, sir, for such a nice talk and very valuable information about the uranium in our state Chhattisgarh. Thank you so much, sir.
Okay. Any question? I think no question. Next.
Any questions?
Next invited talk person. I can see that lady. I think. If any question, we are in same institute. All are welcome to my office, or any time they can phone or mail. Okay, Vikas sir.
Okay, thank you very much, sir.
Okay.
Very nice talk, sir. Thank you.
Thank you. Namaskar.
Thank you, sir.
Now, for next invited talk, I would like to invite Dr. Martha. She is the Senior Associate Professor in Institute of Optoelectronics, Military University of Technology, Warsaw, Poland. She graduated in Physical Chemistry of University of Warsaw, completed her PhD at Military School of Technology, Poland. She did her postdoc in corrosion science at Netherlands. She is the expertise in electrochemical synthesis of nanomaterials. She received 2 awards for her PhD thesis, MUT Rector Award for the Distinguished PhD Thesis, and the Polish Prime Minister's Award for Best PhD Thesis. In 2016, she received the scholarship from Young Outstanding Researchers from the Polish Ministry of Science and Higher Education. She is the principal investigator in 6 big projects. Dr. Martha is co-editor of 2 books, co-author of 42 SCI publications and 5 chapters. Her H-index is 17. She is the reviewer of many high-impacted journals. She is the member of International Electrochemical Society. Today, the topic of her talk is anodic titanium oxide fabrication, modification, and application. So, Dr. Martha, I am inviting you. Please start your talk.
Ma'am, your mic is off. Please on your mic.
Okay. Hello, everyone. Thank you for your invitation and this night's presentation. I would like to present now my presentation, but okay. Please tell me if you see it. It is okay? Do you see it? Do you see
No,
it?
ma'am, it's not. It is not visible. Please. Yeah, it is visible now.
It is visible. Okay.
Yes.
So thank you. So today I will talk about anodic titanium oxide, a few words about fabrication, modification, and application, possible application of that material. At the beginning, I will show you that I am from Poland. Do you know for sure that? If you have opportunity, come and see this beautiful place. We have climate in balance, so this is not too warm, not too cold. So you are welcome all the time. What will be today on the presentation? I will talk a few words about nanostructured oxide layers, anodizing and anodic oxide, about properties, about morphology, and about what we can get when we change the procedure of fabrication. A few words about titanium alloy and titanium anodic oxide application. I will show you part of my newest research, and I hope you will enjoy. Generally, anodization, it is a passivation process which are used to fabricate thin oxide layer on the top of surface of wolf metals. Generally, during anodizing, some metal parts act as anode. This is passive electrode, and some platinum or other part of metals act as a cathode. We can anodize a lot of elements: aluminium, titanium, niobium, thallium, zirconium, whatever we want actually, from this part of Wolf metals. Generally, when we create nanostructure oxide layer on the surface of metal, we enforce current flow between anode and cathode. During this current flow on the surface of metal, we create some kind of nanostructures. These nanostructures chemically is oxides, and on the naked eye, on the visible eye, we can create very beautiful surface, like here or here, in the case of key, or even we can, for example, correlate the implants, if you want. And in the microscopic view, the view of the oxides is totally different, depends on the applied condition. So we can create, for example, barrier oxide layer. So this is dense and continuous layer of oxide without any pores or under nanostructure. We can create spongy type of oxide. So we can create porous nanotubes, nanorods, or other structure. Everything depends on the condition which we applied, and also about use electrolyte and anodizing metal. But the very broad possibilities create a lot of possibilities to application. What is first indicator if we have good or not good experiment? This is current curves. This is the curves which show the change of current density during anodizing time. As you can see here, at the beginning, on the top of metal, we create very dense barrier layer oxide. We can stop at this moment and create, for example, some colored oxide, but we can also go further. And then in the second step, we create small pits where the nanopores, nanostructure start to create. Next, we receive that third stage, and the nanopore create on this whole surface. Then we receive a steady state stage, and the nanopores grow. So then all surfaces are covered by strictly the same nanopores or nanostructure, depends on the condition. And we always, when we create the nanostructure, we always receive the similar curves like this. So this is the first step, second step, third, and fourth. So this is some indicator if our experiments go well. If we receive something different on the curves, we can expect that not everything is okay. In the case of aluminium titanium anodic oxide, mainly two morphologies are created during anodizing. This is nanopores and nanotubes. And now, material science, it is the discipline which focus on the changing of the properties of the materials by changing structure or morphology. And in the case of anodic oxides, these possibilities are very, very broad. We can control the anodic oxide morphology by changing a lot of things together or separately and receive totally different materials with totally different properties. For example, we can change operation condition like anodizing voltage, current, time, electrolyte temperature, type of anodizing materials. We can also change the properties of electrolyte, like pH, viscosity, composition. We can also add additional elements which also influence our properties of oxide. We can also change the experimental setup. This is negligible, but this is very important factor, because when we don't care about it, we receive totally different material. We can also change rotation speed, and this is also affected resultant material. Generally, voltage and temperature of the electrolyte influence on the oxide like this. When we put higher voltage, we have higher pore diameter and higher distance between two nanostructures. When we also apply higher temperature, we receive higher voltage volume of oxides. So this is something what is more or less constant for every used materials. And as you can see here at the beginning, I should tell you this at the beginning, below nanostructure we have some part of barrier layer oxide. This is always in every case, and the thickness of this barrier layer depends on the condition which we applied. Also, time influence our matrix. If we do anodizing for longer time, we receive higher oxide thickness. Also, for longer time of anodizing, we receive better arrangement of nanostructure on the surface. Also, type of used anodizing materials influence very. This is very important factor, because even if we take the same alloy, but in the alloy we have some additional elements which are only alloying elements, the oxide created on the surface of these materials will be totally different and have totally different properties. I can't show you this today because this is not published yet, and we are we're working on this, but we receive very interesting materials with very, very low band gap, around 2 and even below 2, and this is really amazing because the substrate, the difference in substrate composition is only 0.5 atomic percent of some alloying elements. So everything is possible in this case. On the oxide, anodic oxide, the type of used electrolyte influence very much the composition of the oxide layer, and also as we showed in our last publication, age of used electrolyte influence the properties. So now, as you can see here, when I talk about aging, age of electrolyte, I mean the electrolyte which was used to anodizing for some strictly defined time. And for example, fresh electrolyte, it is age of 0 hours, and if we prepare the anodizing on some non-target samples of materials, we age the electrolyte. And for example, when the anodizing in this beaker with electrolyte is conducted for 10 hours, age of electrolyte is 10. If this is after 30 hours, the age is 30. And we find that when we use new electrolyte, the created nanostructure are not very stable and the arrangement of nanostructure are poor. But if we put the same materials with the same condition in the electrolyte with age 10 hours, the stability and arrangement of nanopores are very, very good. And this is something amazing. So we try to find what happened with this electrolyte. We find that during aging of electrolyte, the pH is changing, conductivity of the solution of electrolyte changing, and also ionic concentration inside electrolyte is changing. So these parameters of electrolyte influence the created nanostructure, nanopores. And for example, the influence on physical properties is that the size of nanostructure are changed between samples prepared in fresh and aged electrolyte. Also, chemical composition are changed, mainly in fluoride and titanium content and hydrophilicity, but this change is significantly. This is not a slight change. This is very, very important change. Also, mechanical properties changed. We observed the change in Modu-Young. So also, because of change with hydrophilicity, we observed the change in bioactivity of these materials. For example, in protein adhesion. So, summary, all these parameters like chemistry, pH, conductivity of the electrolyte change during aging of using electrolyte anodizing, and also influence on the properties, strong influence on the properties of resultant anodic oxide. And generally, in fresh electrolyte, we receive a very small, thin barrier layer, and we receive a thin barrier layer, but with when we use aged electrolyte, the thickness of barrier layer is higher. So also we receive the smaller thickness and diameter of nanostructure. We also find that the content of oxide, hydroxide, and fluoride in the electrolyte decreased during the time of anodizing. So if we use aged electrolyte, we have some benefits, but also we lost some properties. So this is very important to choose property electrolyte which you use to your experiment. And this is very important. The choice of electrolyte is very important because normally for anodic titanium oxide creation, the electrolyte based on glycol are used, yeah? And they contain for sure fluoride, and this is normally used for everyone. But we also try to use something new. So we change the solvent in the electrolyte, and we use alcohol, ethanol. Simply, this is alcohol with only one hydroxide group, and we want to find what happened when we change this. And we get totally new morphology of oxide. We create anodic titanium oxide with smaller thickness. The wall of the nanostructure was with rubber on the top, and we receive also the color in some specific condition of this electrolyte. So this changed a lot. As you can see here on this current curves graph, here is the current curves registered for ethanol glycol solution at 40 voltage. When we use electrolyte with solvent with ethanol like a solvent, use it like a solvent, the shape of this current curves was totally different. But we also can find the first stage and the third stage. So only on this shape, based on the shape of the current curves, we expect that something different, totally different was created. And it was true. Other important factor, inter-electrode separation. This is something what is always negligible because nobody cares about it. But This is not my research, but this is very good article, so I recommend to go through this article. If you want to do something with anodizing of titanium, Fan et al., they create some setup experiment when they change the separation between anode and cathode. And as you can see, depending on the distance between anode and cathode, the oxide was totally different. The thickness of wall in the nanostructure was thinner when the distance was smaller. Also, the thickness of oxide, which are normally controlled by time of anodizing, was totally different when we used the same condition and the same time, but different separation between cathode and anode. And this change was very, very critical. And what is important? Another thing is important. When we do anodizing between anode and cathode, the current flow. And during this flow, the negligible charged anions are being incorporated in the structure of anodic titanium oxide, anodic oxide structure from electrolyte. In the case of titanium, we oxidize the metal surface. The cations of titanium are going to electrolyte, and if we conduct this anodizing in some aging electrolyte, we have some complex in electrolyte which are created during anodizing. So also the fluoride, which was before in electrolyte, go through the anodic oxide layer. This is something what can be used for other application. And we prepare some experiment. This is a new experiment. I show you some briefly some selected results. And we simply try to incorporate in the structure of anodic oxide some part of other elements direct during anodizing. We simply use this mechanism and try to incorporate manganese, molybdenum, tungsten, everything. Yeah, these 4 compounds. As you can see here, I create some XYZ condition to not show everything. And but here only the voltage is different. And as you can see here, in the case of X voltage, we receive only barrier layer type of oxide. When we increase the voltage.
Hello, ma'am, you have 5 minutes. Please conclude. You have 5 minutes more.
Okay. So the morphology of oxide is totally different. As you can see here, the change of feature are big. And also, as you can see here, the content of the content of elements that also influence on the parameter of oxide, and also affected the thickness of resultant oxide. We prove that when we change the condition, we also change the amount of incorporated element, and this element strongly affected the resultant band gap of the oxide. So as you can see here, we have some reference samples, and when we create oxide in electrolyte containing additional elements, the band gap, resultant band gaps, in changed. And this change is very good shown for the manganese, for example. These conditions are very good, so we try to prepare new publication on this only. We can use anodic titanium oxide in catalysis, biomedical application, and also CERS. CERS is some new field which are development now by our group. And okay, this is some implant of hip. And you can see here the layer of oxide created on the top to increase the adhesion of proteins on the top. So this should help with the increase of time of leaving this implant. This research are doing under other evaluation actually, but this is also interesting application. Okay, this is something not important. Okay, and as you can see here, at the beginning I told you that anodic titanium oxide have two main morphology. This is nanotubes or nanopores. Nanotubes are shown here, and we find that in some specific condition we can also receive some nanofibers, like here on the right side. And these nanofibers of titanium oxide could be used for application in surface-enhanced Raman spectroscopy, because the Cypher's area is very, very high. And when we combine this with silver or gold nanostructure, we can create very good substrate for cells. This is also doing research now. Okay, so now I want to thank you for your attention. And part of this research was financed by National Center for Research and Development of Poland under my project. And thank you for your attention. I hope I was on time and I don't take more time than I should. So thank you. And if you have any question, please tell me.
Okay, thank you very much, ma'am, for your nice presentation. Manikar sir.
Thank you, ma'am. Thanks so much. Hello.
Thank you.
Hello, ma'am. Martha, ma'am. On behalf of BIT Raipur, I, Ravi Shankar Panikar, take this privilege to thank you once again. So nice to see you again. Hope you remember me.
Of course.
Thank you so
of course,
much.
I remember you. I hope we will have opportunity to meet again.
Yes, ma'am. We are fortunate.
Not online form.
Yes, no virtual. Yes,
Yes,
ma'am.
I hope so.
I would also like to thank Neha, ma'am, for setting the chair, and it was really a very, very fruitful and knowledgeable session. Ma'am, thank you for the time and for your kind presence, ma'am. Thank you very much.
Thank you. It is nice to see you again. I hope we will see in the future in normal,
Yes,
normal
Yes.
procedure.
And our regards to your family, ma'am.
Okay.
Yeah, thank you.
I'll see you.
Thank you, Vikas sir. Thank you very much.
Thank you.
You would like to speak something, sir?
सर
Sir,
ये
next,
केमिस्ट्री के सेशन स्टार्ट करना है ओरल प्रेजेंटेशन
Yes, please.
Yes, ma'am. Please go
okay
ahead.
now we are starting the oral presentation of chemistry. So oral presentation 1.
OP1 from chemistry.
OP1 from chemistry.
Hello, sir, ma'am. I'm audible.
Yes, Shilpa ma'am.
Ma'am, oral presentation 1 is not there.
Okay.
Okay, then 2. Second presentation, OP2.
Jagrati Khicharia, ma'am. Are you there?
OP2, please. There is your screen.
Okay, 2. You have 5 minutes for your presentation.
Jagrati Khicharia, ma'am.
Jagrati Jharia.
Khicharia, ma'am. Jagrati Khicharia. Ma'am, are you there?
Yes.
Jagrati ma'am, are you present?
No.
Okay.
Hello.
Next, OP3.
OP3 presentation, chemistry.
Ma'am, please move forward.
OP4. OP4. OP5. Shilpa ma'am, are you there?
Yes, ma'am, I'm here. I'm here.
Hello.
Yeah, Yamini madam is there. Yes, ma'am.
Okay. Okay, Yamini madam.
Okay.
You may start your presentation.
Yes, ma'am.
Ma'am, what is the serial number of your presentation? OP3?
5.
OP5. Okay, ma'am. Okay, start your presentation.
So, very good afternoon to all of you. I am Dr. Yamini Thakur, Assistant Professor from Government J. Yoganandam Chhattisgarh College, Raipur. I am here to present my research entitled Evaluation of Potential Binders Against Spike Protein and Single-Stranded RNA of COVID-19 via structure-based ligand design and in silico studies. So, these are the overviews of my presentation, starting with the introduction, review, the molecules, the drug likeness and binding affinity, the in silico study, conclusion, and then finally with the references. So, COVID-19 disease is caused by new coronavirus, that is SARS-CoV-2, that is severe acute respiratory syndrome coronavirus 2. This is the basic structure I am dealing with, the spike glycoprotein, the heme glutenin esterase dimer, the membrane protein, the nucleocapsid protein and RNA. And this is the envelope protein. So, the glycoprotein and the RNA, these are the targets of my present study. This is S1 domain and S2 domain and the chain A, chain B and chain C. This is particularly the active site of this particular SARS-CoV-2, and this is the domain which helps the virus to enter in the human body. So, here is the pathogenesis life cycle of SARS-CoV-2. We will see in brief. So, first of all, when SARS-CoV-2 enters to the body of a human being, it enters to the cell membrane, that is through ACE2 receptor, which binds to the glycoprotein. So, our first target is this glycoprotein. Now, after the entry of this virus in the membrane, the RNA, that is plus ssRNA, our second target, releases in the membrane. So, after the release, there is process of translation and transcription takes place. So, from that, proteins are also evolved and also the replication takes place, which generates RNA. So, this molecule again form a new virus that is present and releases in the Golgi body's endoplasmic reticulum, and then through this it releases to the outer body. So overall, the entry and replication in the host cell is represented here. Now, the molecule which we are taking into consideration is hydroxamic acid, neutral polyfunctional molecule, and it consists of pharmacological functionality, basically having the hydrogen bond acceptor, hydrogen bond donor sites, and it is already reported as an anti-cancer agent as well from our laboratory, and as well as binders of DNA, RNA and HSA, BSA proteins. These are the research paper. We can see here the biological activity of the compounds. Now, the reviews I have considered here. Zhang et al., Zhu et al., and many of other scientists have worked on the SARS-CoV-2 studies, basically with the protein molecule, with the main protease enzyme, and with the nucleic acid. Now, the main objective of my work is to study the drug likeness of hydroxamic acid, to do the molecular docking, that is in silico study, and to know the binding affinity towards SARS-CoV-2 spike glycoprotein and plus ssRNA. So, continuing with the methodologies, for drug likeness, we have considered the in silico studies, and basically we have seen the molecules, how much it is effective and how much it follows the Lipinski rule of 5. So we have taken around 15 molecules for the present investigation, and it follows the Lipinski rule of 5, and it shows that it is showing the drug likeness, and lipophilicity were calculated with the help of softwares like Biolume program or BioBite company. So these are the structures of the compounds, the hydroxamic acid. This is the 2D structure, 3D structure, the hydrogen bond acceptor and donor site evaluated, and these are the lipophilicity values. Now, these are again another molecules. From here, the naphtho derivative, that is N-phenyl naphthohydroxamic acid and N-methyl benzohydroxamic acid, are extensively studied because it showing the most potent effect towards SARS-CoV-2. These are other 5 molecules we have taken into consideration. Now, the methodology, main methodology we have taken into consideration is molecular docking, the in silico study. So, basically, docking is the procedure where it can discriminate between good and bad ligands. It is the method which predicts the orientation of one molecule to second when it bound to each other to form a stable complex. So, basically, there are 3 major components of docking, or we can say the methodology, the in silico methodology we had employed here. First, the representation of receptor binding site and ligand. Second, the sampling of configuration space of the ligand receptor complex. Third is the evaluation of ligand receptor interactions. So these are the steps we have to see for molecular docking. The target I have used having the PDB ID 6VSB 6NUD, which was downloaded from RSC PDB site. And the software I have employed, main software I can say here is the AutoDock 4.0 to predict the binding affinity between SARS-CoV-2 protein and RNA. Now, the methodology, the steps we have to see for the docking process. Firstly, we have to see the preparation of target, that is of protein and RNA here. We have to optimize the targets by removing the water molecules, the heteroatoms, and we have to add the hydrogen atoms and charges. And as well as we have to see the grid species also there. And we have to generate the PDB-QT file, that is the main file we have to generate for this target. Now, dealing with the ligand, we have to create the 3D structures of the ligand. Here I have used Marvin Sketch CamDraw and MMT algorithm for the optimization of ligands. The minimum energy molecule must be used here. And now the next step is this molecular docking, which we have done with the help of AutoDock Vina. Here also many algorithms we have to use. Basically here the MGL tools, the PyMol, and the LGA tools we have used, which was used for AutoDock tool file. After that, we have to see the 2D interaction diagram to know the exact location and exact residues or nitrogen bases of nucleic acid where it has been showing the interaction of compound and that particular biomacro molecule. So the visualization is done with the help of PyMol 2.3.4. These are the results.
Please conclude, ma'am. Hello.
Yes, ma'am.
Please
Yes,
conclude, ma'am.
Yes, ma'am. So N-phenyl naphthohydroxamic acid is the major potent molecule here, the 2D structure. These are the interactions we have obtained. So hydrophobic hydrogen bonds and pi-pi stacking. These are the molecules showing all the 15 hydroxymic acid. The plus SS RNA target, we can clearly see the interaction in yellow lines and the nitrogen bases here. Now, the interaction parameter for this particular molecule, that is naphtho derivative of hydroxymic acid. Here also many types of interactions have been shown. This is the interactions of all the other molecules. Now, the main thing we have obtained is the binding energy from the Autodoc Vina, that is minus 7.0, minus 7.0, minus 6.1 and 6.0. So here, representing the naphtho derivatives, the least the binding energy, the more is the stability. Therefore, we are considering these molecules as most potent against SARS-CoV-2. Now, the conclusion here, molecular modeling has been used and showing here different types of bonding here, like hydrophobic pi-pi stacking, and all the molecules are able to interact with SARS-CoV-2 receptors and nucleobases, and we will maybe further use the study and do the in vitro and in vivo studies. These are the references. Acknowledgement. I am very much thankful to my supervisors, Professor Ramapante ma'am and Dr. Elif Mohapatra ma'am. And I would also like to thank our sir, principal sir, Dr. Amitabh Banerjee sir, and our head of department, Dr. P.K. Agnihotri sir, for giving me the opportunity. And I am also thankful to all the organizing committee of the conference. Thank you.
Thank you, Dr. Yamini, for such a nice presentation. Now I am inviting oral presentation 1, physics. Oral presentation 1, physics.
Hello. Neha ma'am.
Yes, ma'am.
I'm sorry to interrupt you.
Okay.
From chemistry presentation, oral presentation 3 and 4 are there, and 5 and 6 are also there. If physics are there, then no issues. We can call them later, but they are there. Priyanka Singh and Sandhya Chindrakar, Sudarshan and Kalpana.
Okay, ma'am.
Okay, so next presentation. Monica Narang is present.
Yes, sir.
Okay, we will present after that. The chemistry presentation is going.
Ma'am, Shilpa ma'am, after Monica,
yes, ma'am.
All your OP3 and OP4 we will continue, okay?
Yes, ma'am. Thank you so much.
So is it visible?
Yeah.
Good afternoon, everyone. Let me introduce myself. I am Monica from Chandigarh University. First of all, let me thank you all for giving me this opportunity to say something in front of you. As you can see on the screen, our topic of today's presentation is synthesis techniques of barium titanate by various routes. The subject of my presentation can be looked at under the following headings. Barium titanate is an excellent piezoelectric, ferroelectric, and a dielectric material. It's a perovskite of type AbO3, and its structure is as shown in the figure. At a temperature equals to or greater than Curie temperature, it has a cubic structure, and below Curie temperature, it turns into tetragonal crystal structure. The size of barium and titanium ions are quite different. It has basically FCC derivative structure. in which barium and oxygen ions together form the FCC lattice, whereas the smaller titanium ions occupies the octahedral interstitial sites in the FCC array. It has been widely studied because of its high dielectric constant. Moving on to the first synthesis, that is Sol-Gel method. It is also called as wet chemical synthesis. It's actually a bottoms-up approach for synthesizing nanomaterials. In this method, firstly, barium and titanium compounds are taken as precursors, like these barium acetate and titanium isopropoxide that I'm taking from a research paper. Then
Shilpa ma'am, please mute your mic. Shilpa ma'am, please mute your mic. Shilpa ma'am, mute your mic, please. Okay, thank you. Please, Monica.
Then these precursors are then dissolved in 2-methoxyethanol and then heated for 2 hours with continuous stirring. Until after evaporation, a clear gel was formed. Finally, after calcination at 650 degrees Celsius for 2 hours, powdered barium titanate was obtained. Here comes the next slide, and I have summarized here the synthesis outcomes of BaTiO3 of various Sol-Gel synthesis. My observation is that the particle size increases with increase in calcination temperature. It's clear that the calcination, as the calcination temperature is increasing, the particle size is also increasing. The nanoparticle size are also increasing from 25 nanometers to 370 nanometers. The next synthesis is hydrothermal synthesis. As the hydro term suggests, it's an aqueous chemical process which is carried out in a stainless steel Teflon-lined autoclave. Moving with the procedure, barium and titanium precursors, that is barium hydroxide and titanium tetraisopropoxide, are dissolved in water, and a precipitating agent like tetramethyl ammonium hydroxide are added to the mixture. This aqueous slurry is then stirred and heated for a few hours, or we say refluxed for 2 hours, and then after cooling, washing and drying, powdered barium titanate was obtained. Finally, it was grounded and we got the nano-sized barium titanate. Moving to the data, it's very clear that how phase changes with the increase in synthesis temperature. As the temperature is increases from 22 to 200 degrees Celsius in this third line, the phase transits from cubic to tetragonal. And now from this slide, we can clearly observe that with the increase in concentration of precipitating agent, the particle size increases. As we can see from these two, how particle size is increasing from 80 to 150 nanometers at 240 degrees centigrade, when the NaOH concentration is being decreased from 5 molar to 1.5 molar. And similarly at 200 degrees centigrade, how the particle size increases from 80 to 500 with the decrease in concentration from 5 to 1.5 molar. Another method for synthesis we can use is co-precipitation method. In this method, we use barium acetate as a precursor dissolved in distilled water with stirring, and then we add titanium isopropoxide dropwise to the reaction mixture.
Ma'am, please conclude. Monica ma'am?
Okay,
You
ma'am.
have 2 minutes. Please
okay,
conclude.
Okay, ma'am. Then we add the slurry is dried and then grinded for at 800 degrees Celsius. Similarly, we can observe from this data how with the change in sintering temperature and holding time, how crystallite size and crystallinity changes. And similarly, in the combustion synthesis, it's a very low cost and efficient method. In this method also, I observed how the 200 intensity of this 200 peak is more consistent with increasing zirconium content, and the average grain size of undoped barium titanate, which was 4.2 micrometers, and for the doped one it became 2 micrometers, how the average grain size decreased. And here comes the same data for solid state method. And there are large applications of barium titanate also. it has very high dielectric constant, and only because of that it has very prominent electroceramic applications, like it's used in ceramic disc capacitors, multi-layer ceramic capacitors. Because of its piezoelectric properties, it is used in PTC thermistors and transducers. And in this era, when we are using the ceramic devices, it has become the most important ceramic to be used in such materials. There is the application in ceramic disc capacitors, and then it is also used in multi-layered ceramic capacitors because it has maximum capacitance available from a thin dielectric, which can be packed into the minimum space in the mechanically robust form. It is very cheaper than other multi-layer ceramic capacitors. That's why we are going to study this. I'm going to study this in the upcoming. Thank you.
Thank you. Thank you so much, ma'am. Now, oral presentation, OP3 chemistry.
OP3 Sandhya Chandrakar madam.
Yes, ma'am.
Okay, Sandhya Chandrakar, ma'am.
Yes, ma'am. Good afternoon, ma'am.
Good afternoon, ma'am. Please start your presentation, ma'am. You have 5 minutes.
Okay, ma'am. Okay, ma'am. Good afternoon, everyone. Myself, Sandhya Chandrakar, under the supervision of Dr. Sangeeta Saha. I'm research scholar from CSWTU, Bhilai. My topic on industrial wastewater treatment techniques. Here contains introduction, important contaminants, sludge treatment, and psychochemical treatment.
Your slides are not visible.
Then please share your screen.
Sir, visible or not?
Yes, it is visible now.
Okay.
You are presenting in mobile now?
Yes, sir.
You are presenting in mobile?
Yes,
okay.
Sir.
Okay. Please go on.
Okay, thank you, sir. My topic is industrial wastewater treatment techniques, and here contains basically industrial wastewater treatment describe the process used for treatment wastewater that is produced by industries and undesirable byproducts after the treatment. Treated industrial wastewater may be reused and released by sanitary sewers and the environment. The most industry produced some waste, although recent trends in the developed world have been to minimize such problems to recycle waste water within the production process. Some industrial wastewater sources here, like textile industries, landfill leakage, gas industries, through the specific pollutants generated, the resultant effluent concentrations can vary widely among the industrial sectors. Okay. Important contaminants of concern in wastewater treatments like suspended solids, nutrients, phosphorus, nitrogen, and carbons, and priority pollutants like organic and inorganic compounds, high acute toxicity. Many of these compounds are found in wastewaters. Refractory organics, heavy metals, and dissolved inorganics. Inorganic constituents such as calcium, sodium, and sulfates are added to the original domestic water supply as a result of waste water use, and may have to remove if the wastewater is to be reused. And the characteristics of industrial feature, basically 3 types of characteristics: physical, organic, chemicals, and biological characteristics due to the contaminants. And physical characteristics are turbidity, colors, odors, total solids, and temperature. And the chemical characteristics are the COD, BOD, and some compounds. And the biological characteristics of wastewater is the BOD and the oxygen required for nitrification and microbial population. Physical characteristics like total solids, odors, and colors, temperatures, Okay, this is are the physical characteristics of the wastewater released to the industry, and the chemical characteristic organic matter like typical examples of included fats, oil, grease, surfactants, phenols, volatile organic compounds, pesticide, and agricultural chemicals. Parameters of organic contents, first of all, discuss BOD, the most widely used parameter of organic pollution. 5 days BOD involved the biochemical oxidations of organic matters. The determination of the BOD involves the measurement of the dissolved oxygen used by microorganisms in the biochemical oxidations of organic matters. Measure the efficiency of some treatment. BOD at 20 degrees centigrade for 5 days is used as standard test. Use bacteria to oxidize biodegradable organics in wastewater samples after incubation. BOD can be calculated by measuring DO before and after incubation. And second parameters of organic content is COD. It oxidized organic matter through a reaction with a mixture of chromic and sulfuric acid at a higher temperature. These can be very useful because COD can be determined in 3 hours when compared with 5 days for the BOD. Inorganic metals and heavy metals. Civil industry discharge heavy metals. It can be seen that of all the heavy metals, chromium is the most widely used and discharged to environment from different sources. Many of the pollutants entering aquatic systems like mercury, lead, pesticides, and herbicides are very toxic to living organisms. Chromium is not the metal that is most dangerous to living organisms, much more toxic.
Sandhya ma'am,
Yes, ma'am.
conclude your presentation.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Okay, ma'am. Basically, my topic is the techniques. Descriptions of main treatment technologies. Okay. Mechanical process and physical and chemical process. Here discussed physiochemical treatment, physiochemical treatment of industrial wastewater. Physiochemical treatment of wastewater focus primarily on the separation of colloidal particles. Here is a 3 main stages. First is the coagulations, rapid mixing of particles, and second is the fluctuations of slow mixing, and third is the sedimentation. Basically, this is the stage of slope removal by solid liquid separation. For this, low, medium, and high rate slatters are commonly used. This rate determined by the speed at which water and sludge produced by the system. Biological treatment here involves 2 types of treatment: aerobic biological treatment and anaerobic biological treatment. Here is references, and thank you, ma'am.
Thank you. Thank you so much, Sandhya ma'am. Now the oral presentation, chemistry.
Kalpana madam.
Shilpa madam, can you please tell me which presentation, number of presentation, OP?
Oral presentation number 4, Kalpana Pandey madam.
OP4, Kalpana Pandey madam, please present your. Please present your work, ma'am. Kalpana ma'am, are you there?
Yeah, watching. आओ ना 2 मिनट आओ ना. Hello. Hello. Good afternoon, ma'am.
Yes, please.
Yes.
Excuse me.
Okay, you are visible and audible. Please forward.
Yes, sir. There is a connection problem. That's why I am not showing my video on this. Sir.
Okay. No problem.
Vikas
Yes.
sir, there is Sadhna madam. There is
Yes.
Sadhna madam.
Yes. Ma'am, good afternoon.
Sir, I am starting my presentation.
Yeah, definitely.
Good afternoon, sir. Myself Kalpana Pandey. I am a research scholar of UTD, CSVTU, and Dr. Shilpa Sharma is my guide, and co-guide is Dr. Sangeeta Sahu. And today my topic is water quality contamination and water pollution. And their content introduction is that water pollution is a broad term that describe any kind of contamination of bodies of water such as river, lakes, or wetland with substance that can pose to human health to nature. It means water is generally water is 70% human body, in which 30 to 40% is bone mass, and it is also required for our body function. Generally, we discuss the water quality. Our topic is water quality. Water is polluted due to many reasons. Some is physical, their odor, and any other problem. Common water quality problem like surface water is get polluted due to facial pollution, and surface water is also polluted by eutrophication. Eutrophication is most dangerous in any agriculture processes. In eutrophication, nitrogen, phosphorus concentration reach in pond and any lake system, which disturb our water cycle and get increase the concentration of algae, which is harmful for our agriculture. Common water quality problem in groundwater, in which is mostly salinity. Salinity is also a major problem in water pollution. Another problem is calcium and magnesium, especially in domestic area. Iron and manganese, which they commonly occur in high concentration in groundwater treatment in easy. Water pollution, basically water pollution is due to human activity as well as waste streams also. Major categories of water pollution are which is due to plant nutrients, organic chemicals, etc. Pollution in stream, which is shown in figure. This figure shows the groundwater pollution in which water animals get infected due to this type of pollution. Here we also show the groundwater pollution. Coastal water pollution, which is also represented in diagram also, and how preventing non-point source pollution, which is done in mostly agriculture waste. Use vegetation to reduce soil erosion, reduce fertilizer use, which is done by organic compost in our agriculture field. Use plant buffer zones around fields, etc. Laws for reducing points are these are two types: Clean Water Act or Water Quality Act. Sewage treatment system is also used for preventing water pollution. Sewage treatment in rural and suburban areas, specific tanks. Primary treatment is also used. Secondary biological treatment is also used in urban sewage treatment, which is also called Clean Water Act. Typical septic, here we represent the typical septic tank system by which we clean the water by any sewage. Primary and secondary sewage treatment, which is shown by diagram. Improving sewage treatment. We also improve sewage treatment, also protect the water from pollution. System that exclude hazard waste, compositing toilet system, working with nature to treat sewage using wetlands and treat waste. Conclusion, here we concluded that what can I do to save water, which is water pollution, prevent groundwater contaminants, greatly reduce non-point runoff, reuse treated wastewater for irrigation, find substitute for toxic pollutants, work with nature to treat sewage. What can you do? Means what can I do for reduce water pollution? Fertilize our garden and yard plants with manure or compost instead of commercial inorganic fertilizer. Minimize our use of pesticide. Never apply fertilizer or pesticide near a body of water. Grow or buy organic foods. Compost your foods. Waste. Do not use waste freshness in toilet. Do not flush unwanted medicine down to the toilet. Do not pour pesticide, paint, solvents, oil, antifreeze or other products containing harmful chemicals down the drain or into the ground. Thanks.
Okay. Thank
Okay.
you, Kalpana ma'am.
Okay, ma'am. Thank you.
Thank you so much, Kalpana ma'am. Now,
Next presentation, Priyanka Singh ma'am.
Ma'am, good afternoon.
good afternoon.
Ma'am, please. Neha, ma'am.
Yes. Am I audible, sir?
Yeah,
Yes.
please.
Okay.
Madam, next presenter is
Shilpa ma'am, please mute your mic.
Ma'am, Shilpa ma'am, after Dr. Sadhana Agrawal ma'am, we will continue the chemistry presentation. Okay?
yes.
Okay. Now I would like to invite Dr. Sadhana Agrawal, Professor and Head, Department of Physics, NIT Raipur, for delivering her talk. Before that, a brief introduction of Dr. Sadhana Agrawal. She has completed her bachelor and master's degree in the physics from the Rani Durgavati Vishwavidyalaya, Jabalpur, and obtained MPhil and PhD in physics from the same university. She has more than 36 years of teaching and research experience. Her field of research is condensed matter physics and material science. She has published more than 85 research papers in the renowned journals. So I am here inviting Dr. Sadhana Agrawal to deliver their talk. And the topic of her talk is dielectric property of rare earth calcium yttrium oxide ceramics. Please, Dr. Sadhana ma'am. A very good afternoon to you, ma'am.
Good afternoon, everyone. Thank you, Neha, for introducing me. Myself, Dr. Sadhana Agrawal, and I am from NIT Raipur. NIT Raipur is an institute of national importance and was started in 1956 and currently offers graduate courses in 12 disciplines as well as PhD and MTech program in each of the disciplines. And I am happy to share with all of you that from the commencing session, MSc program, postgraduate program in chemistry, physics, and maths is started from the coming session, that is 2022-23. So, is my screen is visible?
Yes, ma'am.
Yes, ma'am.
Okay. So, these are some central research facilities available in our institute as XRD, scanning electron microscopy, particle size analyzer, DSC, TGA, etc. And apart from this, these central research facilities, we have various instruments in our department also, which includes muffle furnace, heat furnace, TL reader, TL OSL reader, spectrophorophotometer, LCR meter, FTIR, Raman spectroscopy, solar simulator, microwave synthesizer, etc. So this is, I think, yes, this is my research group. Some of them has been awarded PhD and research of some students in ongoing. The topic of today's talk is on dielectric properties of calcium yttrium oxide ceramics, and this is the outline of my talk. It contains introduction of dielectric materials as well as metal oxides, and here I have taken rare earth as dopant, so this also here. Then synthesis part, characterization, and dielectric and electric conduction behavior. So, as we know that insulators or dielectrics are the substances which do not possess free electric charges under ordinary circumstances, right? So this does not mean that they cannot modify the electric field into which they are introduced. In fact, the most important property of dielectrics is their ability to become polarized under the action of an external electric field. So the atoms and molecules of dielectrics are actually influenced by an electric field, and hence the positive charges are moved in the direction of electric field, while the negative charges are accelerated towards the opposite direction from their equilibrium position, and as a result, dipoles are developed and they produce a field of their own. And this process of producing electric dipole is referred to as polarization. The dielectric material is a dielectric constant of a material. Actually, it is a macroscopic quantity that measures how effective an electric field is in polarizing the material. So as you know that the dielectric constant is also referred as relative permittivity, and it is defined as the ratio of permittivity of the dielectric, that is epsilon, to the permittivity of vacuum, epsilon 0. Yes. So as I have said, calcium yttrium oxide belongs to metal oxide family. So something about metal oxides there. The metal oxides are crystalline solids with general formula MO, where M is a metal cation such as calcium 2+, yttrium 3+, La3+, etc. And O is an oxide anion, which acts as a dielectric material under the influence of electric field. Metal oxides show unique physical and chemical properties, and due to these properties are due to their morphology and highly densified grains, and therefore these can be used for the fabrication of sensors, fuel cells, circuits, capacitors, etc. However, the metal oxide have a narrow band gap with a large leakage current. Some of them, such as HFO2, TiO2 or Ta2O5 and ZrO2, have been considered as high dielectric constant or high permittivity material. Most of the dielectric materials, actually, these are thermodynamically unstable. But here in this talk, I am not discussing about the thermal stability of metal oxides. And here, as we have used here dopant as a rare earth as dopant, so which is gadolinium in this particular case. So you can see here periodic table and position of gadolinium, which is a well-known rare earth element with atomic number 64, and it is silvery white, malleable, ductile, and it also crystallizes in the hexagonal closed pack alpha form at room temperature. Coming to the synthesis part, for this, here material is synthesized using solid state reaction method, which is a well-known method mostly used in our region for preparing compounds or samples. So here for this, all the starting material, that is calcium oxide, yttrium oxide, gadolinium oxide, was taken in stoichiometric amounts, and then the material will then ground in agate mortar and pestle for 1 hour by using acetone as a binder. Then powdered sample were then placed in a programming furnace at 1200 degrees centigrade for calcination, and further the calcined powder was again ground for 45 minutes and kept in furnace at 1100 degrees centigrade for sintering. Because we use this sample for dielectric studies, so synthesized powder was then converted into pellets, and silver paste was brushed on both the sides of the pellets, and finally The pallets were then dried in an oven at 100 degrees centigrade for 1 hour. So this slide shows the XRD pattern for that prepared compound, and it confirms the formation of a single phase cubic structure. And here you can see that in this table that the crystallite size, which was calculated using Debye-Scherrer formula, it ranges from 63.5 nanometer to 69.2 nanometer. These are the images obtained from SIM, and these show the cluster of grain of irregular shape and size, and this may be due to high sintering temperature. So coming to the dielectrical and electrical conduction behavior of this calcium yttrium oxide doped with gadolinium, and this includes dielectric investigation, that is frequency dependence of dielectric constant as well as frequency dependence of dielectric loss. The second part, complex impedance spectroscopy, it includes real part of impedance, imaginary part of impedance, and Nyquist plot or Poiseuille plots. Then electrical modulus spectroscopy again consists of real part of modulus and imaginary part of modulus, and finally the AC conductivity analysis. So as I have earlier discussed with you that the synthesized powder was converted into pellets and silver paste was brushed on both the sides. A pellet acting as cathode and anode. So you can see there, this is a schematic diagram of dielectric measurement. And here the calculations, we can use here the this relative permittivity or dielectric constant for measuring this dielectric constant, which is epsilon r equal to CD upon epsilon 0A, where C is capacitance, D is the diameter of pellet, A is the area of pellet, and epsilon 0 is the permittivity of free space. So also, apart from this, the complex dielectric constant, which consists of this real and imaginary part of dielectric constant, this can be expressed as epsilon as a function of frequency equal to epsilon dash minus iota epsilon double dash. Here, epsilon dash is the dielectric constant and epsilon double dash represent the dielectric loss. So what we can say that naturally iota I equal to under root minus 1. Here dielectric constant is the measure of energy stored in the dielectric material, whereas dielectric loss is the amount of energy dissipated from the dielectric material in the presence of electric field. Also here you can see loss tangent or trend delta, which is the ratio of dielectric constant to the dielectric loss, and it is represented as trend delta equal to epsilon dash upon epsilon double dash. So in dielectric investigations, first one is frequency dependence of dielectric constant, and these figure you can see here, these shows the actually variation of dielectric constant with frequency at different temperatures, and for 0 or what we can say the undoped sample, 0.03 and 0.05 molar concentration of. So you see that with increase in dopant, that is GD3 plus ion concentration, the value of dielectric constant also increases. The increase in dielectric constant may be due to the space charge polarization and orientation polarization. Actually, what happened? Calcium yttrium oxide doped with gadolinium. the vacancies like vacancies or defects or porosity, bonds, etc. present in this compound. So the oxygen vacancies act as donors and exist in the interface of nanoparticles, whereas the positive oxygen vacancies acting as holes and the negative oxygen ions pair to form dipoles, and these give enhanced dipole moment. So that dipole tend to rotate in the direction of applied field, leading to the occurrence of orientation polarization at the interference of nanoparticles, whereas the defects produce a change in distribution of positive and negative ions within the interface, and the positive and negative charge gets moved towards the positive and negative poles of electric field respectively, and giving rise to the dipole moment, and therefore space charge polarization occurs in this case. This slide shows frequency dependence of dielectric loss with all these doping concentration and at different temperatures. So see, as in previous case, dielectric constant decreases with frequency for all molar concentration. Similarly, here dielectric loss shows the same nature as dielectric constant and decreases with increase in frequency and dopant concentration also. So higher value of what we can say this initially the higher value of this dielectric loss is due to the motion of molecules from one quasi-stable state to another quasi-stable position. And as the frequency increases, dielectric loss decreases due to the dielectric relaxation here. Coming to the complex impedance spectroscopy, you can see here, this is actually an electrochemical method by which we could investigate the electrical properties of the compound by the use of an electrical circuit consisting of resistance R, capacitance C, inductance L, and constant phase element Q. The impedance data were successfully fitted by this circuit. You can see here Rendell circuit, RG, CG, RGB, where RG is the resistance of grain, CG is the capacitance of grain, and RGB is the resistance of grain boundary. Now, here you can see that variation of real part of impedance, that is Z dash, with frequency at various temperatures for 0, 0.03 and 0.05 molar concentration. It is observed that the value of Z dash decreases with an increase in temperature and frequency. At lower frequency, the compound exhibits dispersed nature with increasing temperature, and you can see that here at higher frequencies, that is greater than 100 Hertz, relaxation impedance is observed for all temperatures. So at low frequency values, higher value of Z dash was obtained as the charges are accumulated on high density side, due to which space charge polarization occurs. As the frequency increases, the barrier height decreases and charge transfer from high intensity to low density side takes place. As a result, Z dash value decreases. The Z dash value decreases with increase in GD3 plus ion concentration also, due to the aggregation of grains, which increase the area of potential barrier, offering more resistance for charge carriers. And this slide shows imaginary part of impedance for this particular sample and these samples. So, and these are naturally, and this shows variation of imaginary part of impedance, that double dash with frequency at various temperatures for undoped 0.03 and 0.05 molar per concentration of gadolinium ion. As you can see, the value of Z double dash decreases here with increase in frequency. And this shows the single relaxation behavior of the compound. Relaxation time, we can calculate it by using the relation 2 pi omega maximum tau equal to 1. Then coming to, yes, this is given here. You can see here. Okay. So these slides show Nyquist plots or Cole plots. So what are Nyquist plots? Nyquist plot is the graph between real part of impedance and imaginary part of impedance. And it shows the effect of resistance of grain and resistance of grain boundary. And the value of complex impedance on the lower frequency region is due to the effect of grains, whereas in the higher frequency region, it is due to the grain boundaries. And in this case, in our case, with increase in temperature, the resistance of grain and grain boundary decreases. And this shows actually the Debye nature of this particular sample. Complex electrical modulus spectroscopy. This gives an idea about the electrical transport phenomena in compound, and it signifies the effect of grain and grain boundary on the conduction phenomena of particular sample. So electrical modulus is nothing but it is the inverse of electrical permittivity and is composed of the real part M dash and imaginary part M double dash, given by the relation like this: M dash omega C0 Z double M double dash, sorry here, sorry, Z dash, and M double dash equal to omega C0 Z dash. These are the different graphs for real part of electrical modulus. So we can see that here variation of real part of electrical modulus M dash with frequency at various temperatures for all the molar concentration. Again, you can see here in the low frequency region, the value of M dash is almost constant. And this is due to short range motion of charge carriers. And with increase in frequency, the value of M dash increases due to long range scoping of charge carriers. The short range motion of charge carriers is due to the lack of restoring forces required for the motion of charge carriers in the presence of electric field. Imaginary part of modulus, again, you can see that the variation of imaginary part of modulus with frequency, and again it is observed that initially the higher value of M double dash was obtained because this is because of long range hopping of charge carriers from cationic side to anionic side. Further, with rise in frequency, the value of M double dash decreases and becomes saturated because of short range hooping of charge carriers. Because ions are confined in potential well, due to which the relaxation mechanism is attained here. Further, with increase in frequency of about greater than 10,000 hertz, the dipoles orient rapidly in the direction of electric field, and M double dash value again increases. Finally, this AC conductivity of analysis of these samples. You can see here this AC conductivity analysis explaining the electrical behavior of compound, and this figure show the variation of AC conductivity with frequency. In the low frequency region, the AC conductivity is frequency independent, and in high frequency region, you can see here, in high frequency region, AC conductivity increases exponentially And this shows that the compound obeys Johnson power law. This Johnson power law is given here. This is sigma AC equal to sigma DC plus A omega double dash. So here sigma DC is the frequency independent conductivity and A is the temperature dependent term, whereas omega is the frequency and N determines the value of hopping mechanism. For translation hopping of charge carriers, the value of this N, this lies between 0 to 1. That is 0 less than N less than 1. And for localized orientation hopping mechanism charge carriers, the value of N lies between 0 to 2. That is 0 less than N less than 2. So here, calculate values of N for these compounds is shown in this table. And you can see that the value of N increases with temperature, which indicates the conduction mechanism is due to the small polaron hopping. And that means that this compound follow Johnson power law, and it can be used in microelectronic device applications. So that's all from my talk. This is summary I have discussed already. These are some references, and this work is also published in one SCI journal. Thank you.
Thank you so much, ma'am, for the valuable talk. Thank you so much.
Thank you, ma'am. Thank you very much. Any questions?
Next, solar presentation, chemistry.
Okay, ma'am. Thank you. Thank you very much, ma'am. Chemistry, OP5. Silpa, ma'am. Next presentation.
Yes, sir. Just a minute. Just a minute.
Okay.
Hello. Hello.
Yes, ma'am.
Sir, next presenter is there, Priyanka Singh. Priyanka Singh, ma'am, are you there?
Yes, I'm here.
Please present your screen, madam.
Hello.
Yes, ma'am. Yes, ma'am.
My screen is visible?
Yeah, ma'am, your screen is visible.
Okay, okay. Good afternoon to one and all. I'm Priyanka Singh. I'm a PhD scholar at Institute of Environment and Sustainable Development, Banaras Hindu University. And my topic for presentation is role of constructed wetland in domestic wastewater treatment. The contents, introduction, objective, materials and methods, results and discussion, and conclusion. Introduction. As it is known by everyone that water is deteriorating day by day, and the constructed wetland is the natural system which can be used for the wastewater treatment, and because as it is an effective and environment friendly and economic feasible option for sustainable treatment of sewage. However, land intensive has associated and additional traditional wastewater treatment arrangements. The treatment of contaminants in the constructed wetland organization depends on the group of physical, chemical, and also biological processes which certainly occur into the swamplands. which are related in through vegetation, sediments, also the microbial communities. This technology holds a great promise to be applied even in remote areas of the country with limited capital and energy inputs. This technology holds great promise to be applied even in remote areas. Sorry, repetition of the sentence. In near past period, it is seen that wetland system were used to for wastewater treatment and providing this wastewater for various purposes. And the objective, the study deals with two objectives, that is to build the natural treatment system, that is constructed wetland for the treatment of sewage at laboratory scale, to evaluate the performance of constructed wetland for the treatment of BOD COD nutrient for the other secondary treated sewage under the different configurations. The setup was prepared at the vertical flow constructed wetland was prepared at the laboratory scale, and the plant was selected was Typha latifolia and Canna indica. The media was sand and gravel, and the water which has been selected for the treatment was secondary treated water from the STP. The parameters were analyzed at different retention time, that is 0, 24 and 48, 48 and 72 hours. The present study was conducted at the Institute of Environment and Sustainable Development, BHU. The secondary treated sewage was collected from sewage treatment plant, and whose capacity was 8 mld. Sampling and analysis. Sewage samples were collected from the discharge point of STP and brought to laboratory for analysis. The study was performed for 6 months, during which the treatment of secondary sewage through lab scale vertical flow constructed wetland. To each wetland, to each setup, 3.5 liters of secondary treated effluent was subjected and analyzed at different retention time, that is 0, 24, 48 and 72 hours for different physicochemical properties. Sample were collected and analyzed for various physicochemical, that is TDS, alkalinity, total hardness, BOD, COD, nitrate and phosphate. And these are the setup planted with Typha, Canna and the control. And the parameters were parameters which were analyzed in the reference of followed the reference by AFA and result and discussion. It has been observed that Typha and Canna, the concentration decreases as the retention time, as the increase in retention time, as you can see in the graph. This is the Typha and this is the Canna. The wetland planted with Typha and Canna has shown the removal of BOD, COD, nitrate and phosphate during 72 hours of retention time. The removal efficiency of Typha were higher than the Canna, then followed by control. And this is the retention, this is the removal efficiency of the Typha, and this is the Canna, and this is the cumulative of Typha, Canna and control. Control showed the most low efficiency. Conclusion. The planted setup showed a more efficient result in comparison to unplanted setup due to the diffusion of oxygen from the root help the plants to uptake the contaminants into it. During the hydraulic retention study, it was found that BOD, COD and nutrient were best removed in the planted constructed wetland. The performance of Typha latifolia was high due to its modified root in comparison to Canna indica. As you can see in the figure, this is the Typha and this is the Canna. The study observed that the root is the key of uptaking that nutrient. Due to symbiotic microorganism exists in the root. The experiment was performed to check the removal efficiency, and it has been observed that there were no gradual change in its performance after 72 hours. This technology can act as tertiary phase of treatment of sewage wastewater and can be used as means of education to recognize people about low cost and low maintenance for wastewater treatment technology. That's all from my side. Thank you.
Thank you so much, Priyanka ma'am. Thank you very much. Such a nice presentation. Thank you so much. Vikas sir, over from the chemistry. Thank you, participants. Thank you all. We'll meet tomorrow at the same time. That is 10:30. Please join us for the second day of session. Thank you so much. Thank you very much.